Good morning, sir.
Yes, good morning, Plavita.
So we'll be starting off in a few seconds, and we are streaming the video as an unlisted video in YouTube. So our registered participants are watching it via YouTube, and the faculties and those who are organizing this, they will be live in Google Meet.
Yeah. So, what is the program for today? The inaugural session is for 1 hour. So, we'll
So it's for
complete
half an hour.
half an hour. Then you will have your technical sessions.
Yes, sir.
Yes.
So the technical session will start at 11.
So, who will be lecturing first?
Today we have IBM certified professor. He is Mr. Jayesh Parashar. He's a quantum computing professional.
So, he has been already informed about the link.
Yes, sir. Yes, sir. He has been informed.
He is joining.
Yes, sir. He will be joining soon.
So, he will be here during inauguration session also.
Sir, I'm not sure about that if he will join the inauguration session.
So, Lavita, can you send his name and affiliation to me?
Yes, sir. Sure.
Devanga might know.
Yes, sir. Yeah. So I'll just confirm it once.
So your invited lecturer, he will be joining.
Sir, he will join at 10:45. So.
So Plavita, can you send me the names and affiliation of
Sir, I've sent it in the chat
invited
box.
lecturers? Will be delivering the invited lectures.
Yes, sir. I have sent it in the chat box.
Sir, since it is our first time, there's a bit of hassle here and there. So please kindly forgive us for that.
Mr. Jayesh Parashar has confirmed he'll be joining in 10 minutes. So we can start the inauguration ceremony. Plavita and Devanga, please.
Good morning. A very warm welcome to all. I, Plabita Barwa, along with my co-host Debanga Das, on behalf of the Department of Information Technology, Guwahati University, feel privileged to extend a warm welcome to one and all present here. The Department of Information Technology, Guwahati University, under Guwahati University Institute of Science and Technology, is conducting a two-day workshop on cybersecurity with special emphasis on network security and quantum computing on 9th and 10th of January 2023, chaired by Professor Hiren Kumar Deva Sarma sir. We have invited some prominent speakers from the tech industry who have an expertise in their respective fields. Today, on the first day, we have with us Mr. Jayesh Parashar, who is a quantum computing professional, and Professor Hiren Kumar Deva Sharma, Professor, Department of IT, Guwahati University, who is an IoT and network security expert. Tomorrow, on the second day, we will have with us Professor Jyoti Prakash Singh from NIT Patna and Dr. Satyajit Sharma from the Department of IT, Guwahati University.
Devanga, your
The
mic is off.
Yes, yes. The Department of Information Technology, Guwahati University, has been established to facilitate a state-of-the-art infrastructure for different undergraduate, postgraduate, and research programs in the field of computer science and information technology. The department aims at establishing a structured set of lining for inclusive, adaptive, futuristic, and need-oriented studies and research in the domain. Today, we have with us Professor Shikhar Kumar Sarma sir, Head of the Department of Information Technology, Professor Hiren Kumar Deva Sarma sir, Dr. Satyajit Sarma sir, Dr. Bhaskar Deka sir, Dr. Chandan Kalita sir, Dr. Kishore Kashyap sir, Dr. Mirzanur Rahman sir, Dr. Navanita Dev ma'am, and Dr. Parishmita Sharma ma'am for the Department of IT, Guwahati University, who have helped us in conducting this workshop. Firstly, I would like to request our head of the department, Professor Shikhar Kumar Sarma sir, to speak a few words. Thank you, sir.
Thank you, Devanga. Good morning. Uh, Organizers led by Devango and Plavita, other volunteers from the Department of Information Technology, BTech students, faculty members, including the chairperson of this workshop, Professor Hiren Kumar Deva Sharma, participants, other faculty members, staff. I feel it privileged to address this gathering for a very useful and important topic to be discussed over 2 days. In fact, when it was discussed at the level of faculty and few organizers, we felt very, very happy that students from our department has come up with a proposal which was fine-tuned through discussions with our professors to conduct such a workshop. And the topic is not a simple network security, but network security associated with quantum computing. And that has added to the seriousness of the planners and organizers, because a workshop on a very generic topic is perhaps maybe a little bit easier to be organized, but when you plan a workshop, plan some deliberations, plan some discussions, and plan some academic brainstorming on a topic which is not only generic in nature but has specialized angles, then it becomes a little bit tough and tougher for the organizers in two lines. One is to have expertise so that the experts can deliberate on, and secondly, to attract participants, because participants may not aware how serious the non-generic topic may be, or how essential such a non-generic topic for their academics. So few participants may be attracted initially. So I'm sure that the organizers have already overcome both the difficulties with guidance and advices from Professor Hiren. You have already sourced state-of-the-art expertise in the field, and also I could see you could source a good set of participants. And as already Plavita has informed that many of the participants will be watching through the YouTube live streaming. A department, when the department delivers academics, the academics is delivered through different modes. And one of the modes is the discussions and brainstorming sessions and sourcing experts which you do not have locally. And such a workshop, which is organized as part of the whole academics, is essentially an important part of the whole academics, because the expertise that you have in a department for delivering the prescribed courses of study is confined to the available experts at the department or the university or the institution. And as you all are aware that subjects like information technology or say evolving engineering and technology subjects require evolving nature of knowledge gaining. It's not that the theories and practices that are there confined to the textbooks and reference books or available materials are sufficient. These are some of the disciplines which require very frequent updating, and also to be in the journey of contemporary developments. And contemporary developments are very much essential if you want to visualize yourself to be established in the technological field. Unless and otherwise you are aware with the contemporary developments, contemporary and significant updates in the journey, it will be very difficult to establish in the practices, maybe in the industries, maybe in the developments, or maybe in the research. So the essential part of a teaching and learning process is how to cope up with this challenge. And the limitations in an institution, limitations in a structure of an institution need to be overcome. The limitations of having limited or confined expertise, the limitations of having exposures to contemporary happenings, those are to be overcome. And one of the important ways of how those limitations could be overcome is brainstorming on the contemporary happenings, is facilitating trainings and exposures to the set of students to the contemporary happenings. And this is what you have done. This is what you have planned. So I'm sure that the discussions through the invited experts and also in-house experts shall be very much beneficial, and they will be able to expose a good set of interested students uh, to the very interesting field of network security and quantum computing. So quantum computing is said to be the next level of uh, supercomputing, and that requires in-depth knowledge of how to handle the threats in such a different structure of computing. It's not only software, but it relates to the devices. It relates to the security of the devices. It relates to the security of the entire structure of the devices. So when quantum computing comes into the picture, then how the security scenario will be changing, how the people will have to look at differently to that of the traditional security measures and security scenario. So those aspects at the level of undergraduate studies, if you are exposed to, then definitely that will enhance your capacity. And also those who will not be able to enhance their capacity, maybe all of you might not have say a similar level of interest, but few of you will have the opportunity to build your capacity based on the knowledge and information that you will be gaining through the expert deliberations. But few of you, those who may not be say interested that much, also may have some sort of inclination once you are exposed to, because unless and otherwise you are exposed to a new world, uh, you don't know whether you will have future development of interest. So it is essentially the exposure which will create a next set of experts, next set of professionals, and next set of interested students and researchers who may be inclined to the new set of knowledge, to the new domain. So it is not expected that all the participants will be trained and will have similar level of interest, but that the success of such a workshop, such a brainstorming discussion is that at least few of the participants shall have the motivation that they will be exposed to a new and interesting fields of study, and that's where the success of such a deliberation is. And that's why we need to organize such workshops or brainstorming sessions, and I'm sure that at least few of the participants shall be with deeper interest in this field, and they will go into the professional fields, they will go into the practices and researches in network security and quantum computing. And I'm sure the experts, including Mr. Parashar and other faculty members from NIT Patna and other institutes, shall give you the best of the knowledges that are there in the contemporary happening and contemporary development. And I, on behalf of the Department of Information Technology of Guwahati University, would like to offer our thanks to Mr. Parashar and other faculty members and invited experts for giving us this opportunity to have exposure to your expertise. And we hope that in near future we will have expanded collaboration with you, and your expertise shall be very much beneficial for our students. Thank you. Thank you very much.
Thank you so much, sir. Our guest speaker, Mr. Jayesh Parashar sir, is here. Thank you so much, sir, for taking out time from your busy schedule and interacting with us. We'll be starting off with our workshop in a few minutes. The workshop will be streamed in YouTube as an unlisted video. Only the registered viewers will have access to the video streaming in YouTube. The viewers will be able to put up their questions in the live chat box and we will be putting forward their questions one by one. The faculties, along with the organizers, will be watching it via Google Meet. If you have any questions, please feel free to type them in the live chat box, and we will take up the questions towards the end of the session. Also, we will have a feedback form at the end of each session wherein you will have to answer the questions. Certificates will be provided to the participants after completion of the event. Please keep in mind that only those who are able to answer the questions given in the feedback form correctly after each session will get the certificate. The workshop will mainly focus on topics like quantum computing, malware analysis and mitigation techniques, cybersecurity, and cryptography, which are currently quite dominating in the tech world.
Today, Today, we are truly honored to have with us Mr. Jayesh Parashar, who is an IBM certified quantum computing professional and a Qiskit advocate. He is a delivery manager and a senior architect at DXC and an AIML advocate. I, on behalf of the Department of Information Technology, would like to extend a very warm welcome. He will be taking the workshop on quantum computing. Now, without further delay, I would like Mr. Jayesh Parashar, sir, to continue with the workshop. Over to you, sir. Thank you, sir.
Thank you, everyone, and thank you, Professor Sikar. Thanks for the warm welcome and the message that you have given to all students. That is what I have been following. That maybe if we can pass on knowledge to 1,000 people, maybe just like 10 or 15 out of them, if they will take it in the right spirit, it will make a change. So, I'm going to share my screen now, and please let me know if it is visible. So I'm sharing the entire screen. So are you guys able to see my PPT?
Yes, sir, it is visible.
Okay, thank you. And could you please confirm if you are able to see the laser pointer and the red color?
Yes, sir, it is visible, sir.
Okay, thank you very much. So we'll start now, and please let me know if you face any issues with my audio or if I'm going too fast. I have a lot of information to pass on today, and if you think like my pace is too fast, please let me know, and I'll adjust it accordingly. So, in this session today, I have divided it into the two parts. In the first part, I'm going to give an introduction to quantum computing, what it is, how it is better than the present day classical computation. Why do we need quantum computing? What kind of program environment we have to program our circuits for the quantum computation, and in the later half we will do our discussion around the cyber security, and the backbone of cyber security is cryptography. So how quantum has affected cryptography techniques that we use today, and what are the alternates we have, what is going on in the world, and then we'll follow same sorry, I'm just shifting this icon here, so probably you can see my entire screen now. So then we will follow that by a code walkthrough on quantum key distribution protocol if time will permit, and at the end we'll have some QA. So going to next slide. The present day computers that we also call the classical computers, we know like they work on the binary input, so they can process any computer that we use today, whether it is our smartwatch, mobile, or laptop or supercomputer. They all work on the binary information. So initially we feed information in forms of number, we translate our real world problem in forms of numbers, then those numbers are converted to binary because the ALU unit in our CPU only understand the binary, and then finally we get the output. So apart from doing a very fast computations, our modern computers are also able to like accept, store, and present information in different forms. When I'm saying different forms, it means like it can accept information in form of voice, visual signals, and if we talk about robotics, the output that we get is also not only in form of just symbols but also in a physical movement. So, at the high level, we can look at our classical computers. When I'm saying classical computers or the modern computers, it is I am talking about the computers, the laptops and supercomputers, or the computers at cloud we have. So, I'm talking about that. So, at high level, if we look at this computing machines, we can see that at the core of the computations, they are only doing some function evaluation. So we have some operators that we also call functions, and we are giving some operand or data. So those operands are being processed by this function evaluation. So no matter whether we talk about classical computers, quantum computers, or some other computers based on some extraordinary physics, the basic framework of computation remains same. So we give some input, we give some data that is being processed, and both for classical and quantum computers, we try to provide information in the binary format. So we have seen like the computers that we have today. It has made a good progress in last 70 years. It has come from nowhere to what we have today. The supercomputers, those are running like on the teraflops or with more fast operations. So people who probably attending these calls who are in like their 50s, 40s and 50s, they probably have worked with the 386, 486 and Pentium processors. So all this progress that we have seen, the speed that we have gained, the efficiency in terms of energy that we have seen, has come with the one fact that we are able to put more and more electrical components like diode and transistor in the same size chip. The size of transistors are keep getting reduced, and today we are able to fabricate transistors and electrical components on this chips, which are of the size of few tens of nanometers. So now can we go like the same way? Can we create more and more this electrical components and increase the efficiency in terms of energy or increase the processing power? It seems like no, because we have reached the limit of miniaturization. At this level, like the quantum physics takes over, because quantum physics is the physics of very small. So when we talk about scales which are of like few tens of nanometers, at that level some strange phenomena like electron tunneling occurs. And what happens that, like, if you know your transistor, you have a p-n junction and p junction, where like you can turn on the voltage, and then it starts working like a switch. If you make the components further small, then electron tunneling will start happening, and electron will jump over the potential barrier, and that is going to mess up the entire calculation. So we cannot go ahead with the same way we have been doing from last 70 years. Now, if we look at the basic components of our computers, we know like at the CPU we have different digital gates, and the more digital gates you have to use for a calculation, the more time it is going to take. So if we are given with a problem, let's say like you are given with a problem that given a number, you have to figure out whether it is an even and odd. So no matter if that number is like of the 2 bytes, 10 bytes, or thousands or millions of the bytes, you can just simply check the least significant bit, and you can figure out if that number is even or odd. So this kind of problems that we give to computers are, they take a constant amount of time, just one time step we could say. But there are problems that we have to deal with in our daily life, and we have to deal it in our industries, which are very difficult to solve. And if we try to solve this kind of problems with a classical computer or even a super classical computer, I would rather say, it is going to take billions of years to solve that problem. So this is why we are surrounded with the problems in this world, like whether it is a disease like cancer or Alzheimer, or it's a protein folding problem, or it is a like problem of coming up with a good vaccine for a disease, or it is a weather forecasting, or it is an optimization problem in industry. So all those problems are very difficult to solve. So it may look to us that like we have done a lot, but when we look around us, we haven't made much progress because we don't have a right tool to solve these problems. And this type of problems are called like the exponential complexity problems, where if you increase the size of input, the time or memory and energy it is going to solve that problems is going to grow exponentially. One of such problem is a blessing to us, and this is actually a one way function. And this problem is finding, given a product of two prime number, finding the prime numbers that has created that product. And this problem is the basis of the RSA, public key cryptographic algorithm, that we are going to learn more about. But given a 2048 bits of prime product, if you try to solve that with your supercomputer today, it is going to take trillions of years to given a number and to figure out what are the two prime factors that has created that number. So we'll see like how quantum computer has poses a threat to RSA, but at the same time, since quantum computers have shown the capability of solving this kind of complex problem, it could be a blessing to humanity on multiple areas and domains. One of such domain is like the quantum chemistry, where we can probably understand the behavior of subatomic particles, or behavior of electrons in a molecule, and how could we form new material that could take us to maybe different planet. So here are the motivations for quantum computing. Like, yes, one of the motivation is that we cannot just further cram more and more transistors in the same size. It is going to create a problem of heat as well as electron tunneling. So how do we move forward from here? So quantum computing is a solution there also. And also we looked at a lot of problems. Those have remained stubborn to us, and our civilization needs to solve these problems to move ahead. So we need to look at this problem with a different perspective. A different tools could we use? Can we build different machines that can solve this problem using a different physics? And this is what the idea of Richard Feynman, the famous physicist, and who initially thought of building such devices so that we can simulate the nature. So coming to the classical and quantum physics, so here in this chart, you will see that we have different types of physics named as classical, quantum, relativistic, and quantum field theory. So these are the set of rules that are created by classical mechanics, is mainly contributed by Isaac Newton, and quantum mechanics is like contributed by Niels Bohr, Erwin Schrödinger, Max Planck, Einstein and himself. So this set of rules based explains the behavior of the object based on this scales here. If the object is of a size that is greater than like few tens of nanometers, and if it is moving with a speed far less than the speed of light, then those kind of object, the behavior of that kind of object could be best understood with the Newtonian physics. So our computers that we use today are created on the Newtonian physics. But if we have objects which are of the small size of like nanometers of subatomic, or even some, in some cases, some like the molecules, they also depict the quantum behavior. So the object which are small and which are moving with a speed far less than the speed of light, we use the set of quantum mechanics principles to describe their behavior, and this is how we are going to we have created and come up with the idea of quantum computers. So evolution of quantum computing is what I have covered in this slide. So quantum computers were conceptualized in 1970s. As I mentioned, Richard Feynman was the first few people who thought of that and building a computing devices that can simulate nature. Then from year 1980s to 2000s, there were significant achievements made, like the proof of concept, development of mathematical framework, development of theory, like a couple of people like Peter Shore and Love Grover. And Love Grover is an Indian origin scientist. They presented some very famous algorithms. So Peter Shore presented Shore's algorithm that has capability to break the RSA encryption, and Dr. Love Grover, he has given the Grover algorithms where you can like do a database search very efficiently. So this kind of progress has been made, but this was a silent progress because there wasn't any physical quantum computer available that time. So around year 2000, there's a company in Canada named Deva. They launched the very first commercial quantum computers. They even sold one, I believe, in year 2006 or 7 to Lockheed Martin, the company that built the fighter planes in United States. So from there, year 2000, the physical implementation begins. But actual momentum was come around like 2016 when IBM, made its quantum computer available on cloud for free for the entire quantum computing community. And in 2017, there was another milestone when Qiskit, the software development kit for quantum programming, was launched. So nowadays we have like many companies like Google, Microsoft, IonQ, Xanadu, Silicon Quantum Computing, Honeywell, Rigetti, and many more. They are working on their own hardware to build the quantum computers, and not only quantum computers but the full stack quantum solutions. Recently, I mean, last year, IBM has launched their 433 qubit processor, and they are going to launch their 1121 qubit Condor processor this year. So looking at the quantum information, how it is different from the classical information. So in classical bit, when we look at it, it has like it can have a value of 0 or 1, on or off, high or low. But in if we look at the quantum bit, quantum information, it has like two basis states. When I'm saying basis states, I'm talking about the classical equivalent of the qubit. So if we are talking about a two-level quantum mechanical system, like the bit is a two-level classical system. So qubit is a two-level quantum mechanical system. When it can remain in either zero state or one state at the same time. It can remain in a mixture of zero and one state. If you look at it, it is a great like ability, because not only you can represent just one state, but at the same time you can represent multiple states. uh, and that can give you an idea that probably we can do like some kind of parallel computations, and we can run the multiple computation path simultaneously. So here you see these arrows that I have made, those are representing a combination of 0 and 1, both 0 and 1 together. And since we cannot no longer represent this information in forms of numbers, because these are arrows, and if you will think that these arrows are best represented by the vector, the mathematics of the vector. So this is how, like when I initially in the first slide I said we need the input, the operand and the operators. So here our operands, or the data that we feed to quantum computers, is a vector, and this vector is often like represented as a column matrix. So we are going to see more about that, the mathematical form, but it is good to remember that the qubit, when we talk about qubit, it has two basis states, 0 and 1. Like a coin, it has like head and tails, but it can also remain in superposition of two states, and those two states are called the basis states. If we take, instead of a qubit, a two-level quantum mechanical system, if we take a six-level quantum mechanical system like a dice, a dice has six phases, so it has six states. When we are not looking at it, it is in some superposition of all the six states. It represent all six path, all six computational path, all six, those quantum states simultaneously. But when we are going to look at it, we are going to see only one of the basis state. So that basis state could be one, two, three, either, or four, five, or six. So but only one basis state. So a six level quantum mechanical system has six basis states. So there are some tools I talked about that is offered to us by quantum mechanics that we intend to use in quantum computation. So these tools are superposition, the very first one. Second one is interference, and then we have entanglement. So we just seen in the earlier slide like what superposition means, but in this slide we'll see like what notation we could use. So to represent a quantum state, we use the Dirac-Scat notations. So it is the Paul Dirac-Scat notation where we put the state symbol between a vertical bar and a greater than sign. And we, like, if we have to represent a zero state, right here on this block sphere representation, so I will put this zero inside that. This state is equivalent to a column matrix, as I mentioned, or a vector. But once again, like, we have to keep in mind that this superposition is very fragile. So unless we are not looking at it, we are not doing some kind of measurement, we are not interacting, it is not interacting with the environment, the quantum object remain in superposition. But as soon as we look at that superposition collapse, and it will come down to one of the basis states. So if we are talking about a qubit, that is again a two-level quantum mechanical system. If we look at the qubit, it is definitely going to come down to state 0 or state 1. It will not remain in superposition of 0 and 1 simultaneously. So what could be the benefit? The benefit is you can perform calculation as long as you are not interacting or you are not looking at it. Now you will see the contradiction, that why did it take so long to build a quantum computers? Because you have to interact, but at the same time you don't have to interact, because if you will interact, the superposition is going to collapse. So we have to interact in such a way that the superposition will not collapse. uh, we can still like take advantage of multiple states simultaneously, and we'll see that how it is achieved. So we if we talk about the mathematical representation, a qubit or any quantum system, here we are talking about qubit, but any quantum system is represented with a Greek letter phi. And the Dirac notation, it is just a notation, don't worry about it. So in the Dirac notation, we put it under this bar and sign. And then for a qubit, we say it like, we can start with forming a mathematical formula, as it is a part of state 0 and part of state 1 simultaneously as a linear combination. Now coming to interference, like, before we look at it, we need to go back to the dual nature of particles. So we have learned about de Broglie's equation, the equation that tells us that every quantum particles, even the bigger particles, have a wave nature, but that wave nature is not visible in case of a tennis ball. Same wave nature is very much visible. The lambda is large for the wavelength lambda is large for an electron. So every associated with every particle there is a wave, and this wave is not a electromagnetic wave or a mechanical wave, but this is the wave of probability, that is also called the matter wave. So similarly, like in the wave mechanics, the way wave interfere, the probability waves could also interfere. So what we do in our quantum computations, so we have superpositions, and we can perform calculation in multiverse or in different computational path. But when we talk about a particular state, we can interfere based on, like, if we have that state at the multiple places, and if the phase, if those states are in phase, they are going to increase the chances of getting a particular path more focus, or more the outcome that we are going to get will become, like, more probable. So this in this probability wave, we call this as a complex amplitude, or the probability amplitude, the amplitude that we see of this probability wave. And then when these waves are in phase, they create a constructive interference. When these waves are out of phase, they make the destructive interference. And since the probabilities are have to be normalized, so some of the probabilities, all possible probabilities should 8 to 1. If we do a destructive interference somewhere, it is going to increase the chances of getting the right outcome. And I'll encourage you to read more about that, the dual slit experiment with electrons. The next tool we have in our arsenal is like the entanglement. So entanglement is nothing but a spatial correlation. So in entanglement, we can have two objects. They are correlated in such a way that no matter how far they could be on one end of the galaxy, another one could be on the other end, but they can still, like, kind of communicate with each other. They in mathematically, they just form one object. So entangled particle can no longer be just represented independently mathematically they are linked. Spartally, they could be on a different places. And once Einstein called, like, this entanglement as a spooky action at distance, because no matter how far these are, they, like, if you take a measurement on one of this, like, particle, then let's say it collapse to state zero, other will also collapse to state zero, given what kind of correlation we have set up when those two particles were together. And it is not like if you have a pair of shoe, one is like left, another one has to be right. It is not like that. It is like, the what kind of pair it is, whether the left or right, does not even exist before you look at it. So this qubits, those form the entangled pair. Each of them remains in superposition. So there's though are not this qubits are not in a predefined zero or one state at any point of time before those are measured. Only at the time of measurement it decides to collapse either to zero or one. And similarly, like, at the same time, other will definitely going to get collapsed, and it will also have the same state as the first particle. How this signal is communicated, nobody knows. It's an open question. But it has been proven multiple times, and in fact we are using it. You can use it, and when you are going to program your very first quantum program. And the entanglement is very important. Just like in case of interference, we see, like, we need it to boost the probability of some state, where diminish probability of some other computational path. Similarly, entanglement is very important. Without entanglement, using entanglement, we cannot gain an exponential speed up over the classical calculations. So in this slide, I just wanted to give you an idea of the power of quantum computation. So here we are looking at a maze. This maze has many paths. Only one will lead to the final stage. So if we look at a classical approach, we'll have to try one path each time. It is like a brute force. So you have to try many paths, and in one of the path you will get the success. But if you can take advantage of parallel computations using superposition of states, you may able to check all the paths at once. But again, like, if let's say you have a million paths and you have prepared the million combinations, if you look at it directly, the chances of getting the right path is 1 in the million. So how we are going to improve that? So we are going to use the quantum interference. We are going to cancel all the incorrect paths. and we are going to increase the probability of getting the right path. So we can also use in the same way the entanglement, and we can probably collapse few of the results, and we can just simply remain with, like, just a few hundred or so. So all those tricks we use in when we work on quantum algorithms. So this is a very good example to think about and ponder on. There's another example I wanted to give you, again, to clear your doubts and any questions, that how the bits are different than qubits. So if you have 64 bits, that we have on our classical computer, we can only represent one of the combination between 1 and 2 to the power 64. So it can represent a number 00064 times, from 00064 times to a number 111164 times. So you have 2 to the power 64 combination, but you can represent only one at a time using the classical bits. But when you use 64 qubits, basically you can represent 2 to the power 64 states simultaneously. That is equal to this number, which is double the number of sand particles exist on our all the deserts and beaches of our planet. So let's decode the qubits a little bit. As we did see, there is a formula we came up with, but when we look at the mathematics further, the formula comes out to be the state of the qubit, psi, that we also call the wave function, or the column matrix of that qubit, that is equivalent to the C0 times the state 0 and C1 times the state 1. What it means that if you are looking at a qubit, that is in superposition of 0 and 1, if you try to measure that qubit, if you take the measurement, the probability of getting the zero outcome is C0 square, where C0 is a complex number. So each complex number has like two real numbers associated with that, because C equal to X plus IY, right? We know. So similarly, what it means, there's like, again, if you would like to, you are given a qubit that is bounded by this particular equation, then the probability of getting the one output is equal to the C1 square, where you take the C1 and multiplied it with its transpose, and then you get the outcome as a real number. So there is a constant, as I mentioned, since I told you like that the probability of getting zero state is C0 square, probability of getting one is C1 square. So there are only two probabilities, right? When on taking a measurement of a qubit, you are going to get the zero basis or the one basis, right? This sum of these two probabilities should be equal to 1, that we know from the probability law. The sum of all probabilities should add up to 1. So C0 square plus C1 square should be equal to 1. This is what we call the normalization constant, and it is true not only for qubit. If you have a 8 state system, 4 state system, then you may have the complex complete as like C0, C1, C2, and C3, then sum of all those C0 square plus C1 square plus C2 square plus C3 square should add up to 1. That is what we call the normalization constant. Here we look at the mathematical uh, and again, like the graphical representation on a unit circle. So in this unit circle, as I mentioned, we prefer to represent the quantum information with a vector. So this is like a complex number on x and y axis, where the x axis, the projection of vector cuts the x axis. We have like the complex amplitude associated with the state 0. Here the complex amplitude associated with the state 0 will become 1. Here it will become 1 for state 1. And again, like we have represented this information with Dirac's cat notation, as well as a vector. That vector that is represented in form of a column matrix, that is also called the column vector sometimes. So this is just a state 0. As you see, at state 0 we have the x axis, the value of x axis as 1. the value of projection on y is 0. So the value associated with the state 1 is 1 here, the value associated with the state 0 is 0 here. Similarly, we have the state 1, and as we can see, this entire state is being represented as combination of C0 and C1, where the C0 and C1 are represented as a column vector here. Now, as I mentioned, like these are actually the complex amplitudes. So these are the complex numbers which are associated with the basis states 0 and 1. So there are actually four real parameters with with each of this complex amplitude we have two real parameters. If we say c equal to x0 plus iy0, and c1 equal to again w0 plus z, w1 plus z1, something like that. But we have four real parameters here. But we also have the constant of normalization, and also when we talk about the global phase associated with the qubit states, the global phase we ignore in a qubit. So ultimately we can come down to only two real parameters, and these real parameters are the angles that we see in a 3D geometric representation of the qubit. And here we see that theta is the angle that a vector create, our quantum state vector creates with z-axis. So this is our vector here, the psi you see. So the angle that it is making with x is z is theta, and the projection of this vector that is created on the xy plane, this projection, what angle it creates with the x-axis, is called the phi. Using this just as two real parameters, we can define the state of qubit on a Bloch sphere. And again, it is a 3D sphere because this represent not only the state but also the relative phase of what this states are differ with each other. So we see the representation of a qubit, the mathematical representation of a qubit on Bloch sphere is given by this two parameter theta and phi, where the coefficient associated with the state 0 is cos theta by 2, and the coefficient associated with the state 1 is ei phi sine theta by 2. So again, these are the complex coefficient, and in order to calculate the probability, you will have to square this. Also, I just wanted to point out that the state 0 and 1 are the opposite states on the z-axis on Bloch sphere. And there are, like, similarly there are again some perpendicular states. When I'm saying perpendicular means 90-degree apart, but on the Bloch sphere we have made some mathematical adjustments. So the perpendicular states are 180-degree apart instead of 90-degree apart. So just as we seen in the first slide, every computational framework should have the operator and operand, very basic thing. So in case of quantum computers, we represent data in form of vectors. So we have to represent the operator somehow, and the operators in quantum mechanics or quantum computing has to be reversible. So the reversible operators are based explained in mathematics by the unitary matrices. So now you have a matrix that operates, that you can multiply with a vector and you get another column vector or the column matrix. So this is how we perform the operations. So it is a things to remember that data in quantum information or quantum data is represented by the column matrix, and the operators in quantum mechanics are represented by square matrix. So this square matrix has to be a unitary matrix. It has to be reversible. The unitary matrix have their own rule, like if you multiply the unitary matrix with its own conjugate transpose, you get an identity.
Excuse me, sir.
Yeah, sure.
Sorry to disturb you, sir. Sir, that small hide icon and stop sharing icon is blocking the view of the slide actually. So,
Can I hide it? Okay, let me
yeah.
see. Yeah,
Okay. Thank you,
thank
sir.
you about that. Thank you. And how much time we are left with? Sorry, I'm just checking on the time.
Sir, we have time till 12:30, sir.
And what time it is?
11:35.
Okay, we have good amount of time. Thank you.
Yes.
So, the when we are talking about operators, so our operand could be a single qubit. So, in that case, if we have to operate on a single qubit, we have single qubit gates, just like the digital gates in the classical computation. We have quantum gate in quantum computations. So, three of the famous gates are the poly X, poly Y, and poly Z gates. These are nothing but, if we look at it in reference of the block sphere, the poly gates basically have rotate a state vector or a quantum state around a particular axis. So if you are operating a particular quantum state or qubit with a poly X gate, it is just simply going to rotate. If you see, like, you are at the zero state on a block sphere, and if you apply a poly X gate on that, that is going to rotate by 180 degrees. If this is your initial state, you will be rotated around the x-axis. So this is your x-axis, and you will come, when you rotate by 180 degrees, you will come to state one. Similarly, if you are at the state one, if you apply the poly X, you will go to the state zero. Same will happen if you go around the y-axis, so that is the poly Y, or you go around the, but again, like, if you are at the state zero and you go around the z-axis, you will not go anywhere, but you will stay on where you are. So these are the unitary matrices. Those are equivalent to the poly X, poly Y, and poly Z gates. Here I have given an example. The poly X gate is also known as the NOT gate, and it is represented with this capital X symbol. So here we are looking at a calculation on a quantum data, and that data is a simple qubit. It has like a C0 complex coefficient associated with 0 and C1 associated with 1. So now we have replaced this X with this unitary matrix of poly X, and then we are operating it with a column vector. This column vector has the complex coefficients only. We already know that the first one is associated with state 0, second one is associated with state 1, and so on. So when this qubit is operated, we can see that finally, when we apply an X gate on this qubit, it is going to simply interchange the complex coefficients associated with the state 0 and 1. So if we are at the state 0, the complex coefficient associated with this C0, sorry, with the state 0 is 1, and this will become 0. So if you apply an X gate, as I shown you, like, it will just simply going to rotate the state around the x-axis by 180 degrees, you will come to 1. So this information of this 0 is transformed to 1 in this circuit, uh, in this mathematical operations, and that same we can achieve with this simple circuit where the state psi is transformed to psi dash. Here is an example of the quantum circuit. This is a teleportation circuit, but the reason I put it here so that I can give you an idea. So in this circuit, a solid line represent different qubits, as we see here: q0, q1, and q3, q1 and q2, sorry. And all these square brackets, they have some kind of quantum gate. So these are like initialization, and then these are setting some qubit to some particular state. This is an Hadamard gate. It is again a very important gate that puts qubit state in superposition. Then we also have two qubit gates that we did not see due to the constraint of time, but these are the gates that are very important if you would like to do some kind of conditional processing, like we do with the if statement in our classical computations. So we need like 2 qubit, 3 qubit, or many qubit gates to perform conditional calculations or computations. And then the measurements are displayed with this particular symbol. uh, Whenever we take the measurement is recorded in a classical bit, because it is like, your quantum state is going to collapse to one of the classical state that we also call the the base state. So it is only possible to store that result in a classical bit. So classical bits are represented in a quantum circuit as a solid two lines, and then you can also have like the conditional gates that checks the condition of a classical bit, and that can perform a quantum operation on the qubit. Coming to IBM, Qiskit is, this was founded in 2017. It's an open source programming SDK, offered for doing programming on different types of quantum computers. The IBM uses superconducting, but there are other vendors like they are, you know, other companies. They are developing different types of hardware, quantum computers that get operate on different kind of hardware. So Qiskit is again, it's an open source. When launched in 2017, it was built for Ubuntu, macOS, and Windows 7. For every Qiskit programs, there are three steps. Once the in the very first step, you build a circuit that is equivalent to your algorithm or the problem that represents your problem. Once you are done with building that circuit, you can do it in Composer. You can also, do it by the program, by writing a program in Python. And once you build that, you will have to find out an executable device, like a simulator or the real device where you would like to send this circuit so it can be executed. Once executed, you would like to analyze, you would like to see what kind of probability distribution you have got, and then you store that outputs in different variables. You would like to print that, you would like to see the graph, and figure out the next step. So all these things are possible in Qiskit. Qiskit has like the four components, and again you know uh, it was upgraded in 20 in July or August of 2021. But these four elements initially were Terra, Air, Ignis, and Aqua, where Terra is the foundational ground for Qiskit element, and it supports like the circuits and the pulses, where the air has like all kind of simulators it supports, and it permeates over all the Qiskit elements. This is why it is called the air. Where the Ignis components give us the error correction and mitigation, and the Aqua gives us some fundamentals around the real world problems. It gives us like some samples, algorithms, and the functions. Those are specific to either chemistry or optimization or finance, like that. In spring of 2021, the Aqua was replaced with Qiskit Nature Optimization. These are the different modules that has replaced the Qiskit Aqua, where the Ignis is now being migrated to Qiskit experiments to give us a more modular approach. Here is the IBM quantum development roadmap. As you can see, in year 2022, they did launch, as they promised, the Osprey processors that has like 433 qubits. And later on this year, they are on the path of launching the Condor processor that has 1121 qubits. So this is the roadmap. As you can see, by end of year 2026, you know they think like using their nested architecture, they will be having a device that can support up to 100K qubits. So in this slide, I have links. I have put some programs, some simple programs, that those are like, hello world programs for a particular area. So here in the very first program, the link that I have mentioned, I have used the state vector simulator. So what you can do, like, you can prepare a qubit in a particular state, and then you can look at that qubit. Normally when you look at the qubit, it is going to collapse, but the state vector simulator, since it uses only the simulator, it can give you the exact orientation of or on the block sphere, or the location on the block sphere of that qubit. So you can try that program, play around that. And then in the second example, I have used the COSM simulator. The COSM simulator is like running your program. When you use the COSM simulator, it is like running your program on the real noiseless ideal quantum computer. So quantum computers are not noiseless, but when you run on the COSM simulator, you get the perfect results. And basically you can run your circuit hundreds of times, thousands of times, and you see the probability distribution. There's another type of simulator that is available, that is the unitary simulator. So with the unitary simulator, you can come up with a matrix, a unitary matrix that is equivalent to your quantum circuit. So that also I have covered in the simple programs that I have put on my GitHub, and there are other learning exercise I have put there. So if we look at the applications of quantum computing, so those are like there from cybersecurity, from modeling to quantum chemistry, quantum biology, physical simulation, and traffic, and supply chain, and industrial production. So how you capture the light efficiently, or how you can make your batteries better. So we see like we have a broad implication of development of this quantum technology. So why not like we think that it is once we have the quantum computer of sufficient size means like quantum computers that has like thousands of qubits, perfect qubits. Um, and and as per the IBM roadmap, we've seen that maybe that is not far. Once we have that kind of computers, it may definitely trigger the next industrial revolution. So here I'll just stop, for a few seconds. Uh, if you have any questions, let me know, or we can have all the questions later.
So we have a few questions over here. We're just figuring out the questions. We'll let you know in a second, sir.
Okay, sure. So with that, we complete our first half. That is the introduction to quantum computation. Now we are moving to the second half, that is like the cryptography part. And cyber security means a lot of things. How you can make your people aware about the cyber attacks and phishing and like malwares and lot of things. But at the core of cyber security is there resides the cryptography. So cryptography is an ancient thing. It is an art of passing a secret message from one place to another, from sender to receiver. So almost all the cryptography methods they use like a encryption and a decryption key. In case of symmetric cryptography, both encryption and decryption keys remain same. In case of public cryptography, the encryption and decryption keys are different. But the major challenge that we always have with the cryptography is how could we securely transmit the key, because key, if it falls in wrong hand, like an intruder or a eavesdropper that we call, can also decode your message, and it can just simply copy the message, decode it later, do something like that, and will be able to take benefit of that. However, in modern world, we not only like focused on passing this encrypted message, but we are also focused on how we check the integrity of the data, that the message has not been modified, and how do we authenticate that it is coming from the intended party and it is going to intended party. So there are two methods of encryption of messages that we have been using from years, and that is like symmetric and asymmetric method. So in symmetric method, we use the same key to encrypt our message, and the same key is being passed somehow securely to the receiver. Receiver uses the same key they to decrypt the message, and this is the best thing we could do in terms of encryption, because this kind of encryption, if you can securely transmit the key, is perfectly secure. It is kind of nearly unbreakable. So this kind of encryption, the example of this kind of encryption is one time paid and AES, 3DES, and many more. But again, if we want a perfect system, we have to figure out how we can simply generate a random key first of all, and how can we securely transmit it. Then we have the asymmetric cryptography. It is also known as the public key cryptography. So it has like a pair of keys. One is the private key, other one is the public key. So public key is used to encrypt the data, where private key is used to decrypt the data. And this is again like RSA is one of the example of asymmetric cryptography, or the public key cryptography. It works on the fundamentals of one-way functions. So such a function, again, like we talked about, that there are two prime numbers, large prime numbers. The one-way function is in the one way we can, like, multiply them together. That can be done easily even on your like laptop or desktop. But if you would like to figure out, if given a prime product, what are its constituents, what are the two prime numbers that has created this product, not even supercomputers running for trillions of years can help you. So this is the one way functions, means doing a calculation in one way is easy, reversing that calculation is difficult. But if you have a backdoor, if you have a private key, you can, like, do that calculation. And this is how the entire RSA was developed. It is again most widely used cryptography algorithm. So our communication that we are having right now, or any of our the financial transaction on Amazon, or some other shopping websites, your bank transactions, all of them, almost all of them are protected by RSA. Our secure communication, the way we establish it, if we are in a client server environment, the client connect to server, then you can see that, if you look at that lock icon against this HTTPS, if you click on that, you will be able to see the hash algorithm, and the encryption algorithm, that is RSA. You can see the information on what public key you have. The public key that is currently is in use is 2048 bit encryption. It means the prime product that you get is of the 2048 bit long. And using that particular public key, and also an exponent, uh, our our client that we would like to connect with the server actually sends a key, a secure key to server is able to decode that using the private key. And then we exchange data using the symmetric encryption using that key. So in practice we use both public and private key for our web communication, for our transactions. Initially we use public key to create a session, and later on, like within the session, we exchange data using the private key. And private key, by private key I mean the symmetric key, not the public and private of RSA.
Excuse me, sir.
So yeah, sure.
Sir, we have got a few questions from our participants.
Yeah, of course.
Sir, uh, Xavier Gogoi, a participant named Xavier Gogoi, has asked, how can cybersecurity be impactful for humans, sir?
Okay. See, if let's talk about, we are on the right slide. If we have seen that, like, there were algorithm proposed by Peter Shor, right? And that algorithm is capable of breaking the RSA encryption. All you have to do to break the RSA encryption, you can connect to Amazon.in or some other website. You can see the public key information there. If you are able to factor out two prime numbers that you see in your browser, you will be able to break the encryption. What does it mean by breaking encryption? See, our internet is a public channel, right? So when we are communicating with our bank or some website, we are doing some financial transaction. So all this information is available on a public channel. It is going through routers, those Cisco routers and all that hardware that is in place, and someone could listen to that easily, but they cannot make any sense out of that, right? Because it is encrypted. So if you are able to break the encryption, you are able to listen. You are able to listen to the government secrets. You would know about Area 51, right? So this is just an example. You would know like a lot of things what is going on, and those things should not be there for public. Those are not there for public in the public interest, right? So the impact of breaking down the RSA or any cryptography algorithm will be enormous. The world will collapse. So that would be the impact.
Okay, thank you, sir. So there are many more questions too, but we'll continue with the PPT because time is limited actually, sir. So we'll ask
Sure,
the
sure.
questions
I'll
later
try.
on, sir.
Mhm. Yeah, definitely.
Thank you, sir.
So in this slide, thank you. We see like how quantum has poses a challenge for the most widely used crypto algorithm, and as I mentioned, the Peter showed like he showed that the RSA like encryption can be broken using a quantum computer, and this is being done by converting this factoring problem in a problem of finding a period of a function, and then that period could be found with help of quantum Fourier transformation and quantum phase estimation. uh, and it is shown later on using the Shor's algorithm. In 2019, someone showed that we actually need 20 million qubits to break the RSA, the current RSA standard of 2048 bits. But later on, just 2 years after, and there comes the creativity, right? So immediately, just 2 years after, someone claimed that it could be broken with merely 13,436 good qubits. So see the difference, 20 million and 13,000. So at present, we are already at the 433 qubit processor, right? And IBM has a roadmap to build a 100k qubit powerful quantum computers. Even with error correction, out of 100k, we will get, 1,000 good qubits, or out of 100,000, if we get 10,000 good qubits, the implications will be enormous. So with the current development in quantum technology, we see that RSA doesn't look that secure. It may be good for like couple of years, 3 years, 4 years, but people started thinking about that, and they started looking for alternatives. Those are called the quantum safe alternatives, and we will look at that now. So the alternatives we have are of two types. One is the post-quantum cryptography, and second one is the quantum cryptography itself. So in post-quantum cryptography, and there's another term I would like to emphasize on: the harvest now and decrypt later. So, uh, governments are concerned with this harvest now, means like people are storing data now. They might be thinking that like there will be a quantum algorithm or quantum hardware in uh, near future that will help them like decrypt this information. And if you look at the shelf life of your data, so your bank account could have a shelf life of 20 years, 30 years. Your social security number has a shelf life of your lifetime. Their government secrets, they have a shelf life of hundreds of years. So governments around the world are very concerned, especially the government in United States and developed nations. So NIST, that is the National Institute for Standard and Technology, they looked at this problem. We don't have the quantum hardware capable of using the quantum cryptography. So why don't we find the classical cryptography method, again the one-way functions, that we can use in a public cryptography method? Those are not vulnerable to quantum attacks. So they launched this challenge in back in 2017, I believe. Yeah, 2017, and then they received like total 82 entries for general encryption as well as like hash algorithms. And in July last year, the four algorithms were finalized. Those are named as Crystal Kyber, Crystal Dilithium, Falcon, and Spinning Plus. So the very first one is now nominated for the general encryptions. NIST has to decide on building this quantum safe standard by 2024. That is the deadline, and that is coming fast. So they are not proposing now to use that because they are further studying it. There are four other algorithms. Those are kept reserve in case someone will come up with an way to break crystal kyber. Those are like all based on the crystal lattice problems. So they have kept some four other options. Those are using different kind of math in reserve. But this is how the world is preparing for uh, this threat that is posed by development in the quantum computing. Now coming to our topic of today is the quantum cryptography. So again, we have seen in the symmetric way of encryption, we have to have the same key at the sender and receiver end. So the major challenge with the symmetric key, if we can take care of these three things here, we can get a perfect encryption. So these three things are the requirement for one time paid. It says that when you have a message and you would like to encrypt with that message with a key, that key has to be random. It should be truly random. So it should not be predictable. By random, it means that truly random, it means that it should not be predictable. Then the size of key should at least be equal to the size of message. And the third very important requirement is how you securely distribute the key. So these are the three main requirements. If our quantum technology can support that, we will have a near perfect way of encrypting our data. So in order to generate a random key, uh, we have quantum random number generators that we can use. As I mentioned, and you can think of that like if you have a qubit that is in superposition of 0 and 1. If you set up a superposition that is like 50% times the 50% chances of getting a 0 and 50% chances of getting a 1, then you will have a perfect random source, so that you can use to create a secret key. And then you can create a key of your desired size. The distribution of key is again a very important thing, and this is where like all those like quantum key distribution protocols comes in pictures that we are going to look at in further slides. So quantum key distribution is achieved with help of some laws of quantum mechanics. So these laws are Heisenberg uncertainty principle, no cloning theorem, and the measurement collapse. So Heisenberg uncertainty principle tells us that like if we have information on a one axis, like if we know that if we take a measurement along the z-axis in our block sphere representation, we have a maximal uncertainty about what we would get in our next measurement on the x-axis or along the y-axis. So that is what Heisenberg uncertainty principle tells. Then no cloning uh, theorem tells us that it is impossible to copy an unknown quantum state of a quantum object. So if we were given a qubit and we do not know what superposition it is in, we cannot create a copy of that. So without taking a measurement, we cannot copy it. But when you take the measurement, it is going to collapse to either 0 and 1. Remember that we have this measurement collapse things. The wave function collapses as soon as you measure it. So no one, if someone is even listening, to our qubits, they are trying to copy our qubits and see what is going on, the qubit will collapse to either 0 and 1. So these are the three principles that have enabled us in quantum key distribution protocol to securely transmit a randomly generated key. There are two types of QKD protocols, quantum key distribution protocols. Those are prepare and measure. So BB84 and B92 protocols are the example of prepare and measure type of protocol. And other kind of protocol is an entanglement based protocol. So E91 is a protocol that uses the entanglement. Both methods kind of provide the detection and prevention from an eavesdropper, but the later one uses entanglement, and it also uses the chsh inequality to check that whether the entanglement pair is coming from a genuine source or not. Before we look into the protocols, we'll have to go through the polarization of the photon. We need to understand it a little bit because we are going to encode the state of our quantum bit in the polarization state of a photon. So photons are the light particles. Light is an electromagnetic waves. You see this like the oscillations of both electric and magnetic fields are 90-degree apart. So if we have a light coming off out of a source, it is polarized. What it means by polarization means like the electric field that oscillates from this light is basically it is oscillating in all possible directions. So this kind of light is called the unpolarized light. But if we put a polarization filter, like a vertical polarization filters, then the light we will get is will only be vertically polarized light. And then we can put another filter there. And again, by vertical polarized light, what I mean is like the oscillations of electric fields are happening only vertically. So all the photons of light that we get after putting this vertical filter, the oscillations of electric field will be same for all the photons, and those will be vertical. But if we put another filter here that is making some angle with this vertical directions, we'll start getting less and less photons. So photons will still pass through. There are chances that this photon will pass through. There's 100% chance that this photon will pass through this filter if this filter is also vertically oriented like that. But if you change the direction of that filters, the chances or the probability of passing that particular photon that is passing through this filter will decrease. And once these filters are like perpendicularly aligned, um, if this is if vertical, and this will become an horizontally oriented filter, then this photons will never be able to pass through. So we see a probability element. We can we'll see how we code the quantum informations, the qubits we have, or the values we would like to pass in the polarization of the light. So here we see the representation. So we can actually use the polarization of light, and we can pass this photons using the existing optical fiber network. So this is why it is a good method to actually use the photons polarization. So we have our values of the qubits as or the values of the secret bits as 0 and 1. And the way we encode this values in polarization is that we assign the horizontal or diagonally up polarization, we assign it a value of 0, and the vertical and uh, diagonally left photon polarized light, we assign it the value of 1. Similar to the values, we assign some like a basis to our measurement devices, and our measurement devices are the combination of two filters which are oriented at the 90 degrees. So the horizontal and vertical filter, the combination of that is called the rectilinear basis, and the combinations of two filters arranged diagonally, it is called the diagonal basis. So remember, just put some attention here that these are like the combination of two filters and not just one filter. Now, as we have seen in the earlier slide, we know that when filters are like 90-degree aligned, there are no chances that a photon which is either not vertical or horizontal can pass through that. Only a photon that is like diagonally aligned will be able to pass through that, and similar is true for the diagonal basis. So when a diagonal photon is through the rectilinear basis, there is a 50-50% chance that it will either go horizontal or it will take a vertical polarization. So uh, we can see also like a diagonal photon as a combination of a linear combination of horizontal and vertical photon. So a diagonal photon is in superposition of like the vertical and horizontal state. So this is where like the Heisenberg uncertainty principle comes in picture. So now we will try to understand the working of BB84 protocol. So BB84 was developed by Charles Bennett and Gilles Bressart in, of course, in 1984. So this is the very first quantum key distribution protocol, and again it uses the polarization of photons to encode the information. The way the information is encoded is like we give the vertical and right diagonal photon a value of 0, and a photon that is polarized horizontally or diagonal down, we assign it a value of 1. So just like any other security protocol, we have two parties, Alice and Bob. So Alice would like to transmit the secure random key to Bob. So what Alice does is like she has a stream of random zeros and ones, and every time she has a value, she chooses a particular uh, photon polarization from this table here. If she has to send a 0, she can choose either vertical polarization, or she can use this up diagonal polarization, and she can send a photon. If she has to send a 1, she can use either the horizontally polarized light photon or diagonal down photon. And this way like she will transmit all of the components of her random key to Bob. At the Bob's end, he has like two measurement bases. This measurement bases are the rectilinear basis and the diagonal basis. And Bob starts measuring all these photons using either the rectilinear or the diagonal basis, and he chooses this basis randomly. He can also generate a random string and start measuring it. So once the transmission is done for entire key, Bob can actually call Alice, and he can tell Alice that for a particular photon, for the first photon, he uses the rectilinear basis. And Alice sees that like she did transfer either the vertical or horizontal uh, photon that matches with the rectilinear basis. So she says to Bob that yeah, your bet is good. But in this case here we see like Alice did send the one value, and she encoded it as a horizontally polarized light, as we see from this picture here. So one can be coded as an horizontal polarized photon or down diagonal photon. So she sees that Bob has actually taken a measurement not in rectilinear basis but in a diagonal basis. So Bob is going to get some error on this particular photon. So she says to Bob to drop this particular bit. So similar in that way, we can see that Alice and Bob, they exchange the information on basis, not on what bit has been set. So with each of the bases, you can like Bob can still get either 0 or 1. So on the rectilinear basis also he can get 0 or 1, on the diagonal basis also he can get 0 or 1. So no information on the real bit is being passed in while they exchange the information. And once Alice confirms to Bob that, like, which of the bases that he has taken for measurement are good, Bob can form a secure key using all the good measurements, and this can work as a secured random key. However, like some eavesdropper that has like technically superior can like listen to that optical fiber, and in order to see what information Alice has sent, she would be using either the rectilinear or the diagonal basis. But if Alice you know take a measurement, then she has to, first of all, the value of the polarization will collapse if she is using a wrong basis. If Alice has sent 0, with the help of vertically aligned polarized light, and if EU measures it in a diagonal basis, then there's a 50% chance that that photon will either collapse to diagonal left or diagonal right, and it may induce an error. And also now Alice has no idea, because it has actually collapsed to one of the state. Alice has no idea whether it was initially a diagonal photon or rectilinear photon. So she may induce an error, because if she is listening to something, she will have to keep sending that like information to Bob. So she would like to pretend that nothing has happened in between, right? So this is the one way, like, where the measurement collapse helps us detect the presence of Eve. And also Eve may decide that, okay, now she is not going to actually measure it, but she's just simply going to copy that information, and then she will perform the measurement on the copied set. But it is also like not possible due to no cloning theorem, because that restrict us from copying the state of an unknown quantum system, right? So these two principles comes in action, and that helps us like detecting the presence of Eve. How? Because every time Eve is going to take a measurement, there is a chances that she will induce an error 50% times. And then Bob and Alice may decide that out of this, like, let's say they transmitted 4000 qubits and they got like 2000 good qubits, they may decide to compare maybe 100, the values on 100 of this qubits. So this time there is a subset of the key where they are actually going to discuss what Alice really sent, right? So with help of that information, Bob will be able to detect if he was expecting, if he used the right basis, he's going to expect the 0 and 1 what Alice has sent. But since Eve has taken the measurement, she has probably induced an error, 50% chances. Then in that case, Bob will see like Alice sent the 0, but I used the right rectilinear basis, but I got a 1. It means something is wrong. And by merely checking on just 72 bits, they will be able to achieve a confidence level of 99.999999%. So this is the power of quantum key distribution, that it is very robust at detecting the presence of an eavesdropper. Similar to BB84, B92 protocol was launched, and it was proposed by Bennett in 1992. Here, instead of using like the 4 polarization state, Bennett proposed that we will use only uh, 2 polarization states, and those are like the horizontal and diagonal up, that we also call the plus state. If we look compare it with the state on the block sphere, so those are the states 0 and plus. So with this particular uses of non-perpendicular states to represent the values of 0 and 1, you don't really have to exchange the information on what basis Bob has used. And if Bob is using a rectilinear basis, and if he get an um, you know vertical photon, then he would understand that it is the value of one that Alice transferred. And if he is using the diagonal basis, and if he gets an photon that is aligned with the minus state, that is aligned like diagonal down, then he understand that it is Alice has actually sent him a zero state. So that go away the requirement of comparing the basis. All other outputs that Bob gets are discarded, and at the end of the day, similar to the way we did in BB84, they can compare the output to detect the presence of E. Coming to the entanglement based cryptography, E91 protocol was proposed by Professor Arthur Eckert. It's a big name in the field of quantum computing. There are lectures of Professor Eckert that you can watch on YouTube. There is an entire series on quantum information. He's a great guy. So he actually said that like we can take exploit the entanglement, the phenomena of entanglement. And if we have an entanglement source, that lies maybe somewhere in between Bob and Alice, we can prepare the Bell state, an entangled states of two qubits, a pair of the qubit, uh, initially set with a 0 0 and 1 1 state. What it means that like if one party will measure 0, other will also measure 0. If one will measure 1, other will also measure 1. And it is obvious, like if we have a true entanglement source, we send one qubit to Bob, one to Alice. There they take the measurement, and they are always going to match. But there's a twist here, like so it may possible that the entanglement source itself is corrupted. Maybe Eve is sitting there, some eavesdropper is sitting there, and they are pretending that like this is an entangled source, and she's sending zero sometimes, sending one sometimes, so that she has the access to all this information that Bob and Alice are going to use. So in order to avoid that, like the measurements are performed or can be performed in either in two bases or three bases. So here I have chosen like three bases. So Bob can, on Alice end, she can like take the measurement in zx and x plus z basis. That is this is x, this is z, this x plus z basis. And Bob can measure in like z, x plus z, and z minus x basis. Um, then wherever they match on the basis, they can keep the information and they can form a key out of that. If they don't match on the basis, then they can actually use, they don't have to throw that information, they can use that information to actually check on CHSH inequality. That is an expectation value, that is the sum of all expectations values of all the measurement that we take in this particular measurement settings here. The three signs are plus and one is minus, because if you know about the Bayes theorem and Bayes inequality, when the measurement bases are like apart uh, by 22.5 degrees, there we see all this quantum weirdness, and the CHSH inequality will give us a value greater than 2. That is not possible in a classical settings. So this is how we do the E91 quantum key distributions. So apart from that, like there could be errors, of course, always in practical world we have errors all the time. uh, so this we can keep a threshold of this error for maybe 3 or 4%. It means that we can, by comparing 1,000 bits, if we get an error on 40, we can still think that there is no E, but this is a transmission error. Also, we can try with some of the classical privacy amplification methods. We can do create a subset of key, two subset of key, we can XOR them. So whatever partial information you have will become negligible in that case. So I have code again uploaded to my GitHub website, and where I have done the coding and cascade for BB84, B92, and E91 protocol that you can refer later. So that's all I have, and I guess we can take some questions now.
Thank you, sir.
Yeah, thank you. Sorry, are there any questions?
So, sir, yes, sir, we have got some questions.
Sure.
The first question is, do quantum computers still require the use of traditional elements like transistors?
Quantum computers does not require transistors, but quantum computers do require the classical computers. So the way we can take, even if we talk about the Shor's algorithm, there's only one part where we would need a quantum computers, and quantum computers are created if we talk about the superconducting architecture. So they do create this computers using the same technology, same fabrication technology, right? But those are not the transistors that we fabricate. We fabricate Josephson junction, we fabricate capacitors, we try to create an LC circuit, that oscillates. So we actually create an artificial kind of artificial atom there. So, and there are different techniques. Some uses the ions, right? So if we talk about ion Q, they are using the ions to actually perform quantum calculations. So we cannot just use quantum computers, we have to use an hybrid model.
Oh, thank you, sir.
Sure.
Okay. So the next question is, how many qubits can Qiskit handle?
See, Qiskit is a software, it's an SDK, right? So your question should be how many qubits can hardware can handle, and hardware actually propose. So when we are talking about quantum processor, I mentioned about this IBM's development roadmap. So we see like a particular processor can handle this many qubits. So Qiskit is a software, like you are talking to me about, like, okay, C language, uh, uh, how many, what kind of calculation it can do. So you can build on a stake, right? I mean, you can do trillions of calculations with like a digit that is millions bytes long or something, but you will have to create modules. So it is the hardware that has limitation, not the software.
Okay, sir. So the next question we have from our participant Gautam Hazarika is, what level of mastery in physics do we require to pursue a study in quantum computing? Can you suggest a pathway to learn that?
Very good question. Actually, I've been working on that path. So I prepared a list of topics for like physics, mathematics, and computer science. So these are the topics that one should know, and this is why, see, quantum computing is not easy, but it is not something that you cannot do. But it will require some fundamental knowledge, and the knowledge that I am talking about is the same that you guys have been studying in your schools. So this is why we would like to promote the study of quantum computations from high school. Because what you need on the mathematics side, you would need knowledge of the trigonometry, you would need knowledge of matrix vector space, right? You need like some linear algebra. So those are some fundamental things. Similarly, in physics, you would need the knowledge of a little bit of quantum mechanics. You will have to know. You would need knowledge of the Newton's equation of motion that you already learned. But if you know that what are the practical implications, how you can replicate, connect it with the real things which are going on in industry, then you will be encouraged. So not much, but again you have to have knowledge of the fundamentals, and I can share the list of the topics later on when I'll send you guys the PPT, and that can be, that should be sufficient.
Sure, sir. Thank you, sir.
Okay, sir. So the next question is by Nilim S. Bora.
Mhm.
We know that quantum computers can use parallel processing to essentially break encryption, but is
Right.
it the method basically a brute force technique?
See, brute force is checking for some solution one by one, right? So this is why I gave you, when I gave you that example of maze, I told you, like, if you would just like take a measurement without using interference or entanglement, without using your creativity or a good quantum algorithm, then it is like a brute force, right? Because if only one solution is right out of trillions of solutions, then the probability of getting that right solution is 1 in trillion. So it will be same as like you are doing the classical brute force. But quantum computing, when you have a good algorithm, you don't have, you are not doing brute force. You are doing like you are able to translate your thought process in terms of quantum gates and operations, so that you can, boost the probability of a particular outcome while you reduce the probability of undesired outcome. So it is definitely not a brute force thing. It is more than that. It is definitely, computation going on and parallel paths. Some people says parallel world or multiverse. We don't know, but we know how to take advantage of that. So there is some serious physics behind that.
Okay, thank you, sir. Sir, the next question we have is a bit interesting. Please explain the famous coin experiment in which the quantum computer wins 97% of the time. So it is a question by Samanya Adhikari, one of our participants.
Yeah, this is not famous, first of all, and this is probably, you can find it on YouTube. See, I mean, you can do more interesting experiments once you get hold of that. So you prepare some. I don't remember it exactly, but you prepare a coin in the superposition state as a quantum coin. So they call it a quantum coin. This is nothing but a qubit. That is the quantum equivalent of this quantum coin, and you put it in the superposition. Then you take the measurement, and then when other person got the chance, he does something, I mean, he perform an Hadamard operation, so that put it back to the state zero. But yeah, I don't remember it exactly, but it is, now you have some fundamentals on the quantum computing, so you can try it yourself. But try, think about that. When when we think about the Heisenberg uncertainty principle, right, we have to go to the lab. We have to use the laser and see if we are getting a dispersion of light when we narrow the slit, because we have more information on the position of photons. So we are definitely going to have more momentum, spread it across. And you don't have to go to lab anymore. You can do that experiment with a single qubit, right? So when you have a measurement, you are taking a measurement on z axis, that is up and down. You have no idea about what would be the measurement on when you take a measurement along the x axis. And that is what Heisenberg uncertainty principle is, that when you have a perfect idea about one of the property, you have no idea about what would be the state of, I mean, what would be the other property. So if you can send me what that experiment is, it was long ago, I guess 4 or 5 years ago. Someone put that from IBM. I don't remember. I watched it once, but it is not famous and it is not awesome.
Okay, thank you, sir. So the next question is by Mayuri Bashya. What hurdles do researchers face in developing a quantum computer?
Well, one of the hurdle that people were facing, and this is why it did take so long, is the superposition is fragile. So even a train passing by, a metro passing by, or a cosmic ray, could disturb your calculation, because we said like the superposition of a state is fragile. We don't have to look at it, we cannot make measurement. But what I mean by measurement, it should not interact with the environment. So as soon as it interact with environment, it decohere. So there is a term in quantum mechanics that says decoherence. So it gets decohered. It no longer remain in superposition. It will become a bigger system now, part of a bigger system. So it will not help us with our calculation. So but how would you operate if you are given a superposition, a state in superposition? How you are going to operate on that? You will have to somehow interact with that. So you have to interact so that you can operate on that. You can transform that information using some kind of gate, and that gate in superconducting architecture, that is a pulse, right, that they send. So this contradiction and this how to achieve, there are like engineering challenges. How you find a place where there are no vibrations there, like that is safe from cosmic radiations, that is, so they have to cool it down to a near absolute zero. It is colder than the outer space. Outer space is like some 2 Kelvin or so, but it is like some millikelvin. So where all this perturbation, all this disturbance does not interfere, does not create much noise. Um, and 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 this qubits can still operate. So if you see this picture here, your qubits actually resides somewhere here at the down. I think I lost the point, but here your qubits are, and the temperature here is some millikelvins. So this is why it is taking so long. And when you have cables coming out, those cables are here at the near absolute zero. Here the cables are at, like, room temperature. So how many cables you can put? Uh, there are many engineering challenges, and those are been taken over, one by one. So yeah, a lot of people are making good progress.
Okay, sir. So we have another doubt,
Mhm.
or rather, I should say a question. If the data is encrypted with secured public and private keys, then
Mhm.
how DDoS occurs? So it's a question by Prasun Chakrabarti.
DDoS.
Yes, sir.
What is DDoS?
Uh, so,
Okay, you can
Depa-
send me that question if you have the right information, because I don't know what DDoS means. But
okay, sir.
Denial of service attack, sir.
sorry,
Denial of service attack.
service attack, some kind of attack, that is you are talking about. So see, if again, if you know how to calculate, I am not expert of DDoS or some other attack, but on the fundamental level, and it is very important that we look at everything. Our fundamentals should be right when we are talking about. We should always start with the ground. So if you have some way of breaking it, there are many ways in cybersecurity. You can listen to the information. You can have a malware sitting on your laptop that can, like, you don't have to do a factoring. You can just simply see like what password a user is typing. Some hooks, hook software or some kind of other software can listen to that. They can send you an email and get control of your computer or put some ransomware there. So those are a different thing. See, so those are more related with the user's behavior. But at the fundamental level, what we could do to safeguard our data, That is where the quantum cryptography comes in picture. So we are talking about breaking encryption itself with a new algorithm, with the creativity. So this is why we need post quantum cryptography method.
Okay,
Okay,
sir.
sir. The next question is by Alisha.
Mhm.
Is it true that AI can replace the jobs of cybersecurity personnel?
Yeah, we are going in a different domain. So let me tell you, but let me connect it with the subject. See, ultimately, automation is going to replace a lot of people. I mean, the human force. So this is why we need to look at where we could fit in this changing world. This disruption. So this is why we need to align ourselves. If you think the AI is going to replace professionals, or robotics is going to replace labors, where we will fit in this new world. So we need to study. When computers came, like, my father was working in a bank, and people were panicked that computers are going to take away their jobs. But then people started learning IT, right? So uh, they found jobs in different domain. So this is where we need to put our energy. Maybe we can learn AI, maybe we can learn robotics, maybe we can learn you know quantum computing. So this is how I correlate this question.
Okay, sir. The next question is by Sambanay Adhikari. What is the progress and contribution of India in quantum computing field? When can we expect India's first quantum computer, according to you?
Well, the information I have, and again, I've been working, pushing it a lot, uh, writing to many people, including those who should have done something. In one of the budget of 2019, that was proposed by our honorable finance minister, that the India is going to spend 8,000 crore rupees in over the span of 5 years on quantum technologies. And I don't know how much money has been spent, but government has done something. They have formed some collaboration with Amazon, and they are doing something. I did hear that, like, DRDO has made some progress, and the army is also doing, because I live in Indore, that is close to Mahu, and they are working on quantum cryptography methods, because that is of very much importance to the defense, right? As far as we are talking about the processor, I know there's one processor is being built at the Tata Research Institute, TRF, TFR, Tata Foundational Research, and they are working on that. But apart from that, I don't think anyone is involved in the physical realization. There may be some devices here and there, some prototype, but we need to act, and that is what I've been trying to do with my colleagues.
Okay, sir. Thank you, sir. So we won't take much time of yours.
Sure.
So there's one last question from one of our juniors. Actually, it's from yeah. So the final question is like, as we are the coming youth, what is expected from us towards quantum computing, sir? So like, what can be done by our side?
Mhm. See, again, coming to the same point, we would like to teach people this. As I mentioned, this could be something that can trigger the next industrial revolution. So we need to prepare ourselves. What you could do is you can spread the word about quantum computing. You can join some program. You can clear the certification that IBM launched. IBM has launched. You can also become a Cascade advocate. You can find more information about that. And up over above all this fact, that certification and titles, you can prepare yourself for what is coming. You can educate people. So first you prepare yourself. Again, I'm going to share the list of topics, and you can find it also on my LinkedIn profile, but I'll share the list of topics that you can prepare in. make your fundamentals strong. No matter whether you learn quantum computing or AI or blockchain or VR or something, make sure that you know the math. If you know the math, your fundamentals are clear. You know what quantum gates are, what qubit is, how does it work. Then automatically you will be able to build up large things. So everything starts small. It's like a brick, and you put many bricks to build a beautiful house. But everything, your brick should be strong, right? Your fundamentals should be strong. Then you would be able to build, you know maybe one day you'll be able to build a new algorithm. So if you have any questions, I can take other questions for maybe another 5 minutes.
So we actually got a lot of questions, but because of time constraint,
Sure.
we are ending the session now.
Okay.
So with this, we have come to the end of our first session of the workshop. We are very grateful to you, sir, for taking out time to conduct this workshop. Thank you so
Sure.
much. I would also like to thank everyone who have attended the workshop today. Thank you all once again.
Okay. Thank you.
We will be providing a Google form in the comment section. You need to fill up the form correctly to get the certificate. Thank you all once again for joining. Thank you so much, sir.
Okay, thank you. Bye bye now.
Thank you so much, sir. The next session will begin at 2:30 p.m. By Professor Hiren Kumar Deva Sarma on cybersecurity. We expect your active participation in the upcoming session. Thank you, everyone.
Debango, am I audible?
Yes, sir.
Okay.
Yes, sir.
I'm just testing the device in this side. Then it's okay. I'll be available at 2:30, right?
Okay. Yes, sir. No issues.
Form. Thank you.
Yes.
After successfully completing the first session of our two-day workshop on cybersecurity, we'll be starting off with the second session now. For the second session, we will have with us Professor Hiren Kumar Deva Sarma sir, Professor, Department of Information Technology, Guwahati University. He is an IoT and network security expert. He has written two books, namely Information-Centric Networks and Cybersecurity, Issues and Current Trends. He has more than 85 publications and 130 plus papers. He will be taking the
Plabita,
workshop on
Devang,
cybersecurity.
Yeah.
Yes,
sorry to
yes.
interrupt. আমাৰ আকৌ ষ্টাৰ্ট কৰিব লাগিব কাৰণ ষ্ট্ৰীমটো ষ্টাৰ্ট হোৱা নাছিলে অলছ'
Okay.
ছাৰৰ কিবা প্ৰব্লেম আছে মানে ছাৰৰ কিবা টেকনিকেল প্ৰব্লেম দি আছে চ' অলপ পিছত ষ্টাৰ্ট কৰি আছোঁ আমি
Okay.
Okay.
So is the stream live now? Samanya?
Yes, it is live.
Okay. Okay, so we'll start in a few minutes. We are actually facing a few technical issues. So please be in the stream, everyone. We'll start in a few minutes. Hello, sir. Am I audible? Hello, sir.
Devango, you're audible. I think sir is having some issues.
Okay. Good afternoon, sir. Am I audible?
We'll be starting the workshop in a few minutes. Please have patience, we are having some technical issues.
Yes, we can
Yeah,
start.
please continue.
Yeah, Samanya, just a second. So once again, good afternoon, everyone. We will be starting the workshop very soon. So you guys know the usual procedure. It will be the same as before. So the workshop will be streamed on YouTube as an unlisted video. The people having access and the link will be able to view it, just like the previous session. Any doubts and questions, you can put it up on the chat box, and then at the end of the session, we'll probably look into it, and then we'll ask sir about those doubts. And then also do fill up the feedback form at the end. It is very important for the participants to fill it up, because this will record the responses and you'll get the certificates accordingly. So now I hand over to Plavita.
Okay, after successfully completing the first session of our 2-day workshop on cybersecurity, we'll be starting with the second session now. For the second session, we have with us Professor Hiren Kumar Deva Sarma sir, Professor, Department of Information Technology, Guwahati University. He is an IoT and network security expert. He has written 2 books, namely Information-Centric Networks and Cybersecurity, Issues and Current Trends. He has more than 85 publications and 130 plus papers. He will be taking the workshop on cybersecurity. So, without any further delay, I would like to request Hiren sir to continue with the workshop. Thank you.
Thank you, sir.
Thank you. So this workshop is on network security, which is, of course, if we talk about cyber security, then that's a bigger domain. And we will put it this way, that network security essentially it will mean about the security issues in the networks. Now, when we talk about networks, the network might be a campus network, it might be a network in an industry, it might be a local area network in a particular premise. So this way, the networks in this context will be a smaller domain. However, it will have the similar security threats. In the other hand, when we talk about cyber security, it will be in the context of internet users. So we will be using internet in day-to-day basis. Nowadays, nothing is possible without internet access. Every day, we are heavily dependent on internet. So while using this internet, what kind of security issues we have to be aware of. So that will be the prime discussion in this session, right? So there are two things. One, the name of your workshop suggests there are two things. We are talking about cyber security. We are talking about network security. Now, as I have made it clear that network will be in a smaller context and cyber will be in a bigger context, right? So I'll share my screen and I'll also take you through both the things that what I have just told, that is issues with cyber and also issues with some particular networks, right? Hope you have seen my screen. Is it visible? Can anyone tell me?
Yes, sir, it is visible, sir.
Okay.
Sir, could you just hide the stop sharing and hide that icon, sir?
Okay.
Actually blocks the viewer.
Is it okay now?
Yes, sir.
Okay. So before I go into the network security aspect, I will just tell you about certain cyber security issues, right? Now, this term is very much prominent nowadays. Everybody is talking about cyber security, cyber attack, cyber safety, right? And very recently, I have come across one article that cyber attacks that is happening in around in India, it is rising in a very serious manner. I mean, in the sense that the number of cases happening each year is increasing in India tremendously. And that is a concern, right? Apart from that, even if you talk about the states of India like Assam and northeastern states, even this area is also very much prone to this kind of attacks, and it is happening regularly. Right in the beginning, let me share a very recent experience with you. It happened around 2 weeks back. One of my neighbor, he was telling about his experience on that day. It is an incident that took place 2 weeks back in Guwahati itself. What happened? Please listen carefully because these are the trends. This is how attackers they plan new attacks. You and I, we may not be aware of this kind of new attack model. Then they design it first, and experience teaches us actually that this is an attack. So what happened with that gentleman? Just 2 weeks back, two ladies, well dressed, seems to be very gentle. They were standing in front of his house for quite some time. And he has some arrangements. If people stands in front of his house, they can sit. He has made some sitting arrangement. Then these two ladies, they sat there for quite some time. And the owner of the house was observing this. Then he came forward and he asked, "What has happened? Why are you sitting here for so long?" I hope you are getting my words. Am I audible, guys?
Yes, sir. Yes, sir.
Okay. Then they said, we wanted to make a call. So we are not able to make a phone call. Can you please give me your phone so that we can make a call? Then he thought it's okay. So he offered his phone to make that call. They made a call and an OTP came after some time. So these two ladies, they again asked the gentleman, sir, I hope there is an OTP in your phone. Please tell us what is that. He immediately found that message containing the OTP and he told to these two ladies that this is the OTP. Then they disappeared. And this gentleman was quite okay for 1 hour or so. But after 1 hour, he thought, why I have shared an OTP with someone which I should never do actually. And by profession, he is also an employee. So he has some amount of knowledge of these things. Then immediately he thought that if at all something can happen, it may happen to my bank accounts. Then he rang up the call center of that bank where he maintains 2 accounts. Then one is in his own name and one is in his wife's name. Then these call center people, they helped him a lot. And after 3-4 hours, he discovered that using that OTP, which he got in his mobile number, but he shared it with 2 strangers, a new ATM card has been built. And that card has been taken away by somebody from a particular bank branch. And had there been a delay of another 1 hour or so, he would have lost a significant amount of money. So this is what is happening. So this is just an example. So how will you classify it? Will you not name it as a cyber attack? Of course, it is a kind of cyber attack. We are living in a society which is not separated from the cyber world. We are connected. When you receive that OTP, when this OTP is given through some web-based form to some banking applications, probably some transactions or some sort of processing can take place. So everything is happening over web. So this is also a kind of attack that has happened over internet, right? So this way there will be novel attacks every day we will be experiencing, and we have to somehow stop these things so that at least we are safe, right? You and me, at least if every person takes care of his or her own things, then everybody will be safe, right? So most important thing in this new era is awareness. That gentleman, he was aware to some extent, but the society is in such a situation now, in such a position now, that if somebody asks for help in the sense that provide me your mobile phone, I'll make a very urgent call, I think we have to be careful, right? So this kind of interventions, actually interactions, sometimes with strangers, will lead to something very, very dangerous, right? So here is a list of attacks. These are prominent cyber attacks that took place in last year, that is 2022. So if you Google, you will see these are the top cyber attacks. Ransomware attack. Suppose I have some resources in internet. Resources means information, right? I have some access to some server, and that server contains a lot of information necessary for me, important for me. These attackers, what they will do, they will block my access. I won't be able to access that server anymore. And in return, they will demand some money. So if I give that amount of money, my access will be returned. So this is happening a lot, very dangerous. Suppose tomorrow your email access is stopped, not by Google, but by somebody else in between, or not by the mail service provider, but by some third party, and then they demand money. So you give me this much, then I will give your access back. So I think it is very important, because email inbox contains a lot of important conversations, which we heavily rely on that particular thing nowadays, right? So this is the kind of ransomware attack that has happened in 2022 to a greater extent across the world. Okay. Next is IoT attack. So in this discussion, we will focus on IoT attack. I will come to that. But before everything or anything, I would like to tell a little bit about cyber attacks and cyber safety kind of thing, right? So a lot of IoT applications are running, and it is going to increase only. And then what are the various types of attacks that can happen on this particular ecosystem? So that we will see separately. Okay. Cloud attack. So cloud, as you are aware, nowadays almost all IT services are cloud dependent. And in cloud, there are various cloud providers, companies like Oracle, companies like Microsoft. They provide cloud services, and their data centers are also not safe, and they have actually encountered, or they have experienced significant number of attacks in their data centers in recent time. So imagine companies like Microsoft and Oracle, if they are suffering, if they are not able to mitigate these things, then who are you, who am I, right? So it is very dangerous game actually. And then phishing attack. So I hope you are aware, phishing attack, normally some emails will come to our inbox, and these are all unwanted, but they will try to establish a connection with us through that email. So saying something very attractive, or informing him or her to be a known person, so that you respond to them. So this kind of emails keep coming, and phishing attack is very dangerous actually, and it is a kind of social engineering. Okay, I'll come to that later on. And then blockchain and cryptocurrency attack. So blockchain and cryptocurrency, these particular arrivals have not touched many of us so far, but it is going to. And already many are there who are using cryptocurrencies for business purposes and for different purposes. And blockchain technologies are used by industries nowadays. Now, these technologies are also not free from security threats. They also experience a lot of attacks, and this has been one of the trending attack in the last year. Then artificial intelligence and machine learning attack. So here, what is interesting, you see, the entire world is now behind AI and ML, and it has got a lot of popularity in recent time. Unfortunately, this technology can also be used for devising attacks, and that is exactly happening. Attackers, they are using AI and ML technologies and developing a lot of attacks, and many have got success also, means they are able to attack successfully. Then software vulnerabilities. So software vulnerabilities about like software which we installed in our devices. You see, very often, even our operating systems in PCs, the companies, the vendors, they keep us telling then that you update your software, right? So similarly, WhatsApp and Facebook, all these social networks, they keep you informed that you please update your installations. So this is very important, because when a software is developed or designed and developed, then there might be some patches which are not very much strong in the sense there are some security vulnerabilities, right? And later on the developers team, they discover, they experience, and they feel that this should be improved, and then they come up with some updates. So if we do not do these updates, then we are very much prone to different attacks, right? So we have to be careful, and there has to be a regular update of the software patches. So software vulnerabilities also attracted a lot of cyber attackers in the last year. Then bring your own device policies. So BYOD stands for bring your own device. Means in some companies or in some industries, what people say that you bring your own laptop or own mobile phone or any device that you need to use while working. Now, this policy is good in a sense that company will not have any burden regarding these devices. However, if you keep on allowing many people to bring their own devices to a common platform, then along with those devices, many attack patches may come. So many small software programs which are installed in those devices may arrive your company, and from there they may launch different attacks. So this policy is not good. So because of this policy, many companies have suffered in the last year. Then insider attack is very dangerous. People, they will be working inside the organization, but from within the organization they will think a lot of devastating plans how they can damage this particular organization where they are working. So insider attack is about those people who are in the system, but from within the system, they are leaking some information which are beneficial for the attackers. And finally, outdated hardware. So what is this? This hardware technology is improving day by day, and then obviously we have outdated hardware, we have old hardware. Now new software which are developed in recent time may not be able to run over those outdated hardware. Therefore, there will be a mismatch. You have high-end technology or algorithm or software to prevent attacks. However, your old hardware do not support that, right? So outdated hardware is actually outdated. It is no more required. So that is the thing. So these are, I think, 10 different types of prominent cyber attacks that took place in the last year in different parts of the world, right? And our intention in this session is basically to make you aware what is happening in around and how different attackers are planning their attacks. And as a information technologist, your responsibility will be to devise techniques, to devise methods which can stop this kind of attacks, right? And coming to a very important term in the same line, social engineering attacks. So what is social engineering? So I hope you are aware of this particular class of attacks. So what happens here, people will try to establish a emotional connect with you, and from that particular association they will try to divulge the secret information like your account id, your account number, your say credit card information or credentials. Okay, so all these confidential information which are supposed to be very much private to the user only, they will try to divulge. And if they are able to do this, then at a later stage, they will use this information for their own intentions, which will be dangerous to you, right? So this, for an example of Zoom users, I hope you are aware of this particular platform. Since COVID-19, Zoom actually picked up. A lot of people started using Zoom for this kind of meetings. What we are doing it now over Google Meet, right? So there is a huge information user base of Zoom. Now, in last year, 50,000 Zoom users, they experienced this kind of thing. So a fake website, they will pretend to be the Zoom website and they will ask you to log in. So when you give your login credentials, they actually extract it from you, but it will not lead you to the actual Zoom platform. But your credentials are leaked, so that you will not get to know immediately, but at a later stage you may also come to know that yes, this has happened, and sometimes you are not aware, right? So therefore, in those days, many organizations they said that we will not use Zoom because Zoom has a lot of security issues. So it is not only Zoom; any online platform can have these security issues, right? Okay. So I have just touched upon some security threats that took place in recent time over cyber world. Now let us focus on IoT networks, right? So as the name of workshop says, cyber security with emphasis to network security, right? So network security. So I will focus on IoT network security mainly. Okay, so now I'd like to show you one slide here. Yeah. So security issues in Internet of Things. So this is going to be the topic now. You see, this is the user base. 30.9 billion devices are getting connected by 2025 over Internet, right? So this large IoT network is going to be. And what is expected? Low cost. People are not ready to pay a huge money to use a particular technology or application because it is not affordable. Of course, there will be some people to even use the costly technology. For example, Apple computers are not cheap, but still they have a huge user base, right? So that's a different class, but you cannot reach everybody with costly technology. So technology, if you intend to reach everyone, then it needs to be low cost. However, look at this particular trend. So this is a statistical data available in the URL given in the at the top of this slide. So this is 2010. So we are at 2023 now, and then 24, 25. So by 25, 30.9 billion users will be there, or devices will be there in internet, which will be connected to devices. It is not user, it is number of devices which will be connected to the internet. So this blue line, it indicates IoT devices, and this black line it indicates non-IoT devices, right? So IoT devices, when they are connected to internet, you can now imagine the volume of this particular network. So this IoT network is also suffering from different security threats. So in this discussion, we will focus on IoT networks, right? Now, when you talk about IoT, what is there in IoT? Okay, so just go through this slide and try to understand what is there in IoT. Okay. I will I will take you through some examples of IoT applications. Then you will understand better. However, you consider any IoT device or IoT network, that particular device is going to have a transceiver unit. So what is a transceiver unit? That unit is responsible, or it can receive signals and transmit signals. Okay, so it might be a sensor node, or it might be anything, any device, but having one transceiver unit. So if it has a transceiver unit, it has a communication unit, right? So apart from the communication unit, the IoT device will have a processing unit. So processing unit, what it will do, it will process information, it will process data, right? It's a computer basically, right? A microprocessor or maybe a microcontroller, right? Depending on the device. And then sensing unit. So if it is a sensor-based device, then it has a sensing unit. It will sense the environment, and that sensing resultant will be an input to the system. And that input will be processed and output will happen. That output will actually dictate some other actions. Right. And then apart from all this, sensing unit, processing unit, communication unit, there is a power supply unit. So power supply means energy. So it needs energy. The device needs energy in order to operate. Now, these devices can be in three different states. It can be active, it can be idle, or it might be in sleeping mode. Now, if it is active, as you know, active means it is doing some work, okay? Some processing, some sensing, some reception, some transmitting, something is happening. Idle means it is not doing much work. It might be listening to the channel and doing nothing else, right? Or sleeping. Sleeping means absolutely doing nothing. So these are various states of the sensor nodes or IoT device, and these states are essential in order to maintain a optimal level of energy utilization, right? Because suppose a device is not necessary to sense now, then why its sensing should be on, right? So let us stop it, then it will save some energy. So this way, this kind of arrangement is necessary. So before we go to IoT network, I just wanted to tell you what is there in IoT. So IoT device or IoT node, whatever you say, it has these essential units. And if it is a sensor-based unit, it has a sensing unit also, right? Fine. So I think I will go to the next slide now, where we will be dealing with security part only, right? So till now, is it okay? Can anyone give me a feedback whether I am able to reach you or you are able to get it? Can anyone tell me?
Yes, sir.
Okay, fine. Now you see security issues in IoT networks. So we are now coming to this network security part if we consider IoT networks, right? Now in this particular discussion, so this timing is slightly, I initially planned it to be at 10 to 10, 11:30. So it is just, it can be changed from 2 to 2:30 to 4:30, 2:30 to 4 p.m., right? Yeah. So these are the various topics that I'm going to cover in this presentation. One is how a user will look at IoT security. Means, suppose I am a user of IoT networks, then what is security for me? That is the first part of this discussion. Second is a computing person's perspective. Like, suppose the device or the network is maintained by a particular company, then how that company will look at it means IT security. Their job will be different, right? They will look at the problem from computing perspective. They will talk about algorithm. They will talk about hardware. They will talk about different technical terms. However, for user, those are meaningless. Those are not necessary to know. The user will only focus on his gain or loss, right? And finally, there is one RFC. If you are aware, RFC, request for comment. So what it is, I will tell you at the time when I show this. So this is one must read for everybody. If you want to do something in IoT field, so this RFC one should read. It is available freely now. It is open now. You can download it. I will show that. Okay. And finally, some security projects. As you are BTech students, if I am not wrong, so you always have an intention to do some projects. So some project idea we can float, we can discuss here itself. So these are the 4 different perspectives or parts of this discussion now. Okay. Now, from user's perspective, so from common man's perspective, why IoT security is important. Okay. Now, IoT security is important for users, for devices, for organizations. Okay. So IoT devices must be secured. They must be protected, right? So IoT devices must be protected. When you look at the examples, you will see why this protection is required. So it will be too early to give an example. I will take you through some examples at a later stage. Okay. Now you see, if you want to make this IoT ecosystem secure, there are actually 3 different parts. 3 different parts of this system. One is control unit, the other is management, and third one is setup of connections between devices. Let me check if I have that diagram. Yes. Now see, this is the database, backend database. Okay. From here data will come. And this is command and control center. So this is the main part in this particular system from where the processing will take place. And through APIs, these are different APIs, application program interfaces. And through these APIs, different users or devices, they will get connected to this command and control center. And command and control center will take data from the databases and then it will be processed. And accordingly, results will be given back. So, if you want to protect this system, what all you have to protect? You have to protect users, devices, and organizations. How will you do that? Control, management, and connections. You have to ensure security at that control, command and control center. And also you have to ensure security to those devices which are connected through the APIs to the command and control center. Okay. So if you can protect the system, it will keep data private. It will restrict access to devices and cloud resources, and it will finally keep your system secure, right? So everybody and anybody will not be able to access data. So you will restrict that access. Your data will remain private, provided you have proper security system. And how do you do that finally? Suppose I say I will ensure security to IoT. So how will you do that? So in order to do that, you have to have cryptography in place, right? So cryptography is essentially about, it will talk about encryption, decryption, access control, okay? Then what is that called? Different type of algorithms in order to encrypt and then decrypt, okay? And also you have to ensure that what data is actually presented to you is correct. It is not something else. It is what was intended to actually. So if this kind of guarantee can be given, then you can say that yes, my system is secure. So who will give you that guarantee? So cryptographic applications, right? Cryptographic algorithms. Okay. Now, problem is, or challenge, what are the challenges with IoT security? There are many challenges, but major reason why it is so difficult is the IoT device which we connect to the IoT network is very, very limited in its computing power, in its memory, and in its what? In its processing power for running different cryptographic algorithms. Because cryptographic algorithms are normally not simple, right? Computationally intensive. So if you want to run those cryptographic algorithms, your device has to support it. So you have to find out a balance. So that's not easy. And even if you have implemented best practices for security, new attack vectors are constantly emerging. Like I gave you an example right in the beginning of this presentation. So if you have noticed how new attack vectors are emerging every day. Till a few instances, you will not understand that that is an attack. Right, and this way many people are suffering. So when new attacks are emerging, how will you come to know that this is going to lead to an attack? So initially you do not know, and that was the motivation why I gave you that real example that happened 2 weeks back in this place only, right? Now, what are the IoT security breaches? And how, suppose I have a IoT application, I am interested to use it and I am using it. But at a later stage, I understand that this IoT device, although I am using, because of this, these are the problems I am also suffering. Okay, so if that happens, then you will lose confidence on this system. And that is exactly happening in around. The IoT systems which are actually in market, which are used by different consumers, they are not happy. And because of that, 90% of consumers lack confidence in IoT device security. And this is a result of a research done in different parts of this world. Okay, a survey made in 2019, it was done in Australia, Canada, France, Japan, UK, and US. It revealed that 63% of consumers even find connected devices creepy, right? So people do not have trust. And if you do not have trust on this technology, you will not use it. And if you do not use it, you will not be able to realize the potential of this technology, right? It is very simple. Actually, in the beginning of any new thing, people will not believe that. For example, net banking. We were scared of it for quite a long time. You may not know because you are relatively at a later stage, you grew up. But we know that initially we were not very much friendly with ATM card users. we did not want to use ATM cards. Better we will go to the bank offices, put forward the check, and they will give us money in hand. So that practice was there even in spite of the fact that there are so many ATM machines installed here and there. So it takes some time to win the trust of the users. Okay. Now, IoT system is not simple. So that you have to understand. The entire IoT ecosystem is complex. Okay. And a lot of things are automated. So automation is maximum. And the entire ecosystem, what is happening in behind the screen, so that is not very, very clear to the users. And the entire processing is little complex. I'll show you that through a diagram. So this IoT security is a growing concern, and security measures are to be adopted. Okay, so devices are to be made secure. The entire ecosystem needs to be secure. Fine. So as I told you that I will take you through some applications, then you will have better idea where the attacks can happen and where you can have some problems. So you see, there are different types of IoT applications and almost all failed. I mean, there is hardly anything free from the influence of internet. And very recently, in the recent past, this growth has been tremendous actually. The IoT applications have reached almost all areas. Okay. So smartphones, smartwatches, smart home, then air conditioning machines which are intelligent enough, okay, door clocks which are intelligent enough. So these are various IoT applications, and normally you can classify them as consumer application. Then business application. So wide range of IoT devices, including smart security cameras, trackers for vehicles, ships and goods. Okay, so for different industrial environment, sensors are deployed in various parts of the premises for monitoring and also taking some actions on some particular situations. So there are applications which are classified as business applications. Okay, then governmental applications. So government also make use of a lot of IoT networks or IoT systems like tracking of wildlife, monitoring traffic congestion, then natural disaster alerts, etc., etc. And if you are aware, I am not sure, we have seen this kind of systems in recent past. Like in our case, you have many, especially on roads, there are when the traffic is too high, you will see one single person may not be able to handle so many vehicles going here from here to there, and there are certain instances when a particular vehicle driver, he commits something wrong, and then he can manage to fly away from that place. Somehow he goes away and he doesn't come under the police system. So somehow he manages his flight, right? Now, point what I want to make here is, if you have a lot of cameras deployed on roadsides and continuously taking video of every vehicle passing by, and then even the number plate that is specially recognized and stored, then at a later stage, even if somebody is able to fly away from that place, you can catch them, right? So this kind of systems are already in place, and of course it has connections over internet across multi-parties, right? So police department, then other departments, this is a complete ecosystem actually. The camera will be installed on roadsides. There will be networks connecting different departments, and total road, what is happening on that particular road is being monitored and also is being decisioned. At certain points, the AI application can take decision that this car has to be stopped in the next point, right? So these are various applications. Normally, government they deploy, right? They installed because road safety and etc. These are looked after by government only, right? Then the number of IT devices worldwide, it is very huge already. It is discussed, right? And it is used even for agriculture monitoring purpose, then health monitoring purpose, in sports, everywhere, right? Already I have told you that there are three main components. One is database, the other is command and control center, and then it is API. So in that block diagram we have seen, okay? So these three different parts are to be protected if you want to actually protect the entire IoT system, right? Okay. Now, there are different vulnerabilities and different areas where you have to fix the security issues. So what are those areas? Let us see. So one is unpatched vulnerability. So what happens here, the software which are installed in the command and control center for getting data from the databases and also giving connections to different APIs through which different users will come in or the end users will come in. So these softwares in the command and control center may have some vulnerabilities. And if it is there, it will lead to many problems, right? So outdated software are to be really removed, and those are to be updated from time to time, and continuous assessment is required. So what is happening in the system? Is there anything wrong? And if it has happened, where is the source? So continuous investigation, continuous monitoring is required, okay? Then weak authentication. So when you allow some end users to be a part of an ecosystem, how do you do that? You, of course, authenticate a new device to use the IoT ecosystem, right? But how do you do this authentication? So this authentication needs to be very strong. And this authentication mechanism is a problem at many a times, okay? And because the device, it comes from the manufacturer. So from there, the life cycle of IoT starts actually, when it is in the manufacturing plant. It is not that when I buy that device or I become a part of the IoT network, from there life starts. No, the life starts at the manufacturing level itself, right? So this authentication has to be very strong. And then APIs, as I have shown you the block diagram here, these APIs through which different devices will get connected to the command and control center. So these APIs are sometimes vulnerable, right? And those APIs are to be protected or checked. So they may become a threat center where attacker will plan different attacks through these APIs, including man-in-the-middle attack, okay, and distributed denial of service assaults. So these are various threats man in the middle, as well as distributed denial service, then code injection, etc. So these APIs are very, very vulnerable. So you have to be careful with this API part. Okay. So what are the threats to the users? Like as I'm saying that there will be different perspectives. We will look at this IoT system from user's perspective. So as a user, what are the threats to me if I am a part of this IoT ecosystem? Data theft. My data might get leaked or it might be stolen by somebody. Then physical harm. So what is physical harm? Just one example I'm giving. I think I just mentioned about it without going into the details. In healthcare sector, IoT is finding a place. Okay, so for different healthcare applications, people have devised different applications. An example, pacemaker. So pacemaker, heart monitoring devices, and also defibrillators. So if you are aware, defibrillators are devices. What they do, they can actually protect the heart with respect to the maintenance of a normal heartbeat. Okay? So if the heart is exhibiting abnormal heartbeat, in order to bring it to the normal range, that can be done by sending an electrical pulse or shock to the heart. The device to do that is defibrillators. Okay, so these are established technologies now. And nowadays, cardiac arrest is one of the most dangerous disorders or disease in recent time. Even healthy persons who are very regular in going to exercise centers or gymnasium, etc., they also suffer from this kind of things. But what is the wrong with the body? So this is a disease of the heart, actually. Okay, and which fall under the class called CVD, cardiovascular diseases. So under CVD, if heart does not get enough energy in order to pump out the blood, so that leads to abnormal pulse rate, right? And this can be maintained by giving external electric pulse or electric shock. So in order to give this, you need a device to do that, right? So using these devices, that can be done. But now extension to that is IoT. So this device is connected. My heart might be connected through IoT devices, and in another end, a doctor might be monitoring, and he might be actuating also or regulating the device also. So if the doctor receives some wrong information about my heart condition, and he may actuate something which may not be necessary, and why will he not receive the actual reading of my heart? Because there is some attack in between. Some attacker may, what they may distort the original reading. They may bring some changes to the reading. They may give some false data to the doctor. So this is dangerous, right? So it is not that IoT devices are free from all sorts of attacks, and we can use those without any tension or without any with 100% confidence. So that is not so. So these are the physical harm kind of thing, and it is a threat to others also. Like the moment I use a device as an IoT device, I become a part of a larger network, right? So I become a node in a very big network, and then I can be used by some attacker as a part of his plan in order to launch distributed denial of service attacks through botnet kind of technologies. Okay, so botnet, what happens in case of bot network? So it is a malware which will infect the connected devices across the network, and it will install its agent in millions of devices, and at the same time, in a planned manner, they will launch attack, right? So this botnet and DDoS attack, they go hand in hand actually. And if I become a part of the IoT ecosystem, I might be helping others in establishing their botnet. So that is something we have to actually think of. Now, how will you manage then this security as a user? So far, we are talking the user's perspective. So what I should do as a user, I have to protect myself, right? So proactively notifying users about devices running outdated software or operating system versions. I should always update the software. Number two, enforcing smart password management. So I should not continue with the default password. Also, I should not continue with the same password for quite long time. So I should enforce this change in myself, right? Disabling remote access to a device unless it is necessary for core functions. So don't permit this device to get accessed by a remote device, okay? And unless it is very important to do so. Then introducing a strict access control policy for APIs. So when we buy APIs and make use of it for our own purposes, we must apply strict control access policy or access control policy, right? Access control policy. So we must establish the rules, and those rules should be strict enough while taking a decision when this API will make an access to a particular database or not, right? And then protecting command and control centers from compromise attempts and DDoS attacks. So these are the various IoT security management practices which we can adopt at user level. Okay, fine. Now, there are four types of vulnerabilities. One is communication attack. Second is life cycle attack. Third is attack on the device software. And fourth one is physical attack. It will directly target the chip or device. Right. Now, communication attack, as you know, in IoT, communication is essential. You cannot bypass this. So this attack, these communication channels are to be secured. Okay. And life cycle, I will come to this life cycle through that RFC. I told you that it starts at the manufacturing level. From there till you finish that device or you end the use of that device, this entire lifespan, you have to actually maintain this security thing, right? And this is a practice. Sometimes we feel that once we start using a particular IoT application, we will add security to it, right? So it's not like that. Security is not a cap kind of thing that you will wear it whenever you want to do so. It's a mistake. You have to think of bringing this security thing into the ecosystem right from the beginning. When that device is planned, when that particular application is conceptualized, since then you start thinking about the other side also. That if this happens, the negative side, you assume that there are attackers waiting to attack the device, right? So if you do that, then you can perhaps save the system. Security concerns are to be thought of right in the beginning, not after development of the system. security design has to go hand in hand along with other system development activities. Okay. Industrial IoT ecosystem, IIoT. So this is a buzzword nowadays. So IIoT, because industries, they find it to be very, very beneficial if they deploy IoT in their premises. They can really save a lot, they can earn a lot, they can make optimal use of their resources. Especially in the industry 4.0, this has become a standard, like use of IoT for various reasons inside the industrial environment. Okay, so you have to save this industry system against different cyber threats. Okay, so there are different ways by which you can enhance the security of IoT networks. One is device security, then try to ensure data integrity, confidentiality, and privacy, and end-to-end ecosystem security. End-to-end means where from the data is generating and where finally it is going to reach. So this entire channel has to be actually protected, right? So data integrity, confidentiality, and privacy, these are the security goals. I think you are aware are all cryptographic or network security related books. Any book, if you read, you will find all these definitions, and this is essential. So you have to ensure this, then only you can tell that the IoT security is achieved, right? Look at this security architecture, end-to-end security architecture. Please observe this diagram carefully. So there are different IoT service users, then IoT service provider, and IoT service provider is a third party in between, but they will also rely on the platform, I mean, where the cloud or the database will reside. Okay, so that platform is provided by somebody else. Then devices are always with you or the end user. And of course, that device will become meaningful when another service provider enables you to make use of the network, etc. And finally, this connectivity service provider. So these are various entities. This is how they are connected. You see towards left, it is our position, IoT service user. And towards right, top corner, you see these are the devices which we will use in order to make the IoT ecosystem work appropriately, right? So this entire system has to be secured or protected. Now there are two types of connections. One is through solid line. Solid line means it is the trust relationship, main trust relationship. So the trust relationship between service user and service provider, that is the main trust, right? And similarly, IoT service provider and the device itself should not have some malware installed in it, for example, right? So that device and the service provider, they are also in a direct relationship, main trust. Other links, if you see, these are dashed lines because these are supporting trust relationships. Okay, supporting trust means not like main this thing relationship with service provider. So with this, whatever we have discussed so far, although I have a lot of content, but now so far what we have done is basically a little bit about cyber security and a little bit about IoT security. So is it okay? Can I go ahead?
Yes, sir, you can go ahead.
Yes, sir.
Okay. And Now you look at this computing person's perspective. So far, whatever we have discussed, that is user's perspective. Now, in computers or in computing person's view, they will look at three things. One is the processing, how the processing is happening inside the system. They will look at communication, how the communication is happening, and they will also look at the storage, where the data is stored and how is it stored. Okay, is it safe? So, if you talk about communication, these are different types of communication that will happen: device to device, human to device, human to human, and device to human. So D to D, H to D, H to H, D to H. Okay. Now there are different types of threats. One is passive or active. That is type A. So passive means what? Suppose two persons they discuss something. A third party will keep on listening to their discussion. He may not do anything to their discussion, but what will happen? Your conversation is leaked, it is open to a third party, so that is passive. Okay, active means what? Suppose I am sending some data and that data is caught in between and that data is actually altered, so that is active attack. Suppose I was sending a message to you that I am coming and somebody has caught it in between and changed it to I am not coming, so entire meaning is different now, right? So that is active attack. Similarly, internal and external. Then key-based attack, data-based attack, impersonation-based attack, physical-based attack, that is type C. And type D, identity-based attack, location-based attack, eavesdropping-based attacks, manipulation-based attack, and service-based attacks. Okay, so these are different threat models in the context of IoT security. Okay. And these are security goals. Already I have told: integrity, availability, confidentiality, authentication, authorization, auditing, and non-repudiation. Okay. IoT security requirements. Now, in order to make your IoT security work, so these are the requirements. So what do you require? You require cryptographic algorithms. You require key management techniques. Cryptographic algorithms are for what purpose? For encryption and decryption. You may use symmetric cryptography. You may use asymmetric cryptography. But ultimately, your aim is to keep the security intact. Okay. So cryptographic algorithms, then key management techniques, then secured routing algorithms. So when you will route data from here to there, so that routing algorithm should be secure enough, and then data classification. So depending on the sensitivity of the data, some data might be highly sensitive, some data may not be so. So depending on the type of data, you may be able to classify them, and you might be giving them customized level of security. So if the data is highly sensitive, give highest level of security. If data is not so sensitive, you may control it by using lightweight security algorithms also, right? And finally, protecting devices at production time. So when these IoT devices are manufactured or at the time of production, you have to think of protecting it, right? So these are various security requirements, like how you will make the device secure. If you have this, then only the device will be secure. One is trusted and staged boot sequence. So when you start the device, so that booting sequence should be trustable, right? Then secured operating system. Applications should be secure enough. credential management. Credential means passwords and all those things. Encryption, proper encryption algorithms are required. Network connections are to be made secure. Software updating should be regular. This is something very, very important because the developers may not be able to know about the security models which are present today or going to come tomorrow. But by the time the device is installed and it is being used, some new attack vectors may come in. And then it is possible to address these new attack vectors only through updates. So these updates are to be installed properly. It is very important. Okay, and secured event login. So logging details should be made available. Then low power embedded device energy efficiency is addressed here. Heterogeneity, secured access control, identity management, privacy, trust management, distributed IoT networks. So these are some of the IoT security issues. Already I have touched upon some. For example, low power. I have already told that these IoT devices have limited battery power and they have limited processing power as well. So, and moreover, heterogeneity is something is standard now. You cannot have all the IoT devices coming from the same manufacturer or same vendor. It is not possible. So heterogeneity is always there. So you have to somehow address this. Okay. So these are various IoT security issues. Now look at this protocol stack. So this left side, if you look at the left side of this screen, then these are some standard TCP IP based protocols at different layers. Okay, link layer, network layer, transport layer, and application layer. What are the protocols running in these respective layers? Those are mentioned here. If you look at the other side, that is right side of the screen, you will see again different protocols running in IP Smart Objects Protocol Suite. So here you get the 6LoWPAN, which is running in network layer, is actually the IoT network protocol, actually, right? So this is this works in the routing layer. So this is IoT protocol stack, which may be helpful in order to visualizing the entire IoT network system, how this system works, and what are various algorithms or protocols running in different layers, right? So this is the entire IoT architecture along with the protocol stack, okay? So if you look at the left part of it, you will see physical layer, data link layer, network layer, transport layer, application layer, and then cloud services, and then IoT applications. So what are those IoT applications? These are written here. For example, healthcare, I have already given you an example with respect to the cardiovascular diseases, and then home automation, smart city, intelligent transport systems. These are various, applications. Only a few, okay? This list is very large, actually. And then you have cloud services for device management, for business, for business solutions, okay? So this is about cloud services, and similarly, these layers have different protocols running at their level. So those are just mentioned here. So in order to know more, you have to read these protocols one by one in details. How do they actually provide this, they define services to the ecosystem, right? So IoT hardware includes sensors, wearable devices, digital gadgets, microcontrollers like Arduino, Raspberry Pi, and embedded hardware. Already I have just mentioned only, but here it is written clearly. And similarly, these are different IoT software and firmware, operating systems like Tiny OS, then cloud software such as Nimbus and Hadoop. Okay, Hadoop is again used for big data processing purpose also, right? And then insecure communication networks. See, communication channels are always open, so you have to make this communication secure over insecure channel. So that is a challenge, in fact. And data leaks from cloud. So cloud, when you rely on cloud, you purchase this service from service provider and you start taking the service, but there is always a chance that your data might get leaked, right? So these are various challenges in this particular thing. Okay, how much time do I have? How much time do I have now? Yeah, 4.
Yes, sir. Our sessions were till 4, but you can take up a little bit more time, sir.
Okay. So I'll try to come to the end quickly. But before that, I would like to show you that RFC, that is very important actually. Okay. So these are different threat vectors. I think some of them you know. For example, eavesdropping, then ransomware. I think I have already told you. Then malwares in the wearable devices. Then denial of services. So these are different IoT specific attacks. Okay. And then so DDoS attack is actually very difficult because it is launched in such a way that when you understand that you are under attack, it is very difficult to recover from that. Okay, and it is massive actually when they do it, and this is launched through botnet kind of thing. And botnet is not new; it is there for quite a long time. And huge amount of traffic at DNS servers made many websites stop working. I mean, if this kind of attack is launched, it will actually finish the service providing capability of the servers for their intended clients, and finally they will deny providing the service, right? And how can you make your IoT network secure from this? So these are all project topics actually. As already I told you that I will give you some project ideas. So this can be considered that way. Like telnet based attack. So this telnet is what? It is a kind of remote access, right? You access some computing resources from a remote place by login to the telnet software, right? So this telnet based attacks, so there are different attacks what will surface when you have this kind of access model from remote. So how to prevent your IoT ecosystem from telnet based attacks? So this could be some projects, okay? Device algorithm to do that. Similarly, DDoS attack. So what are the various DDoS attacks that can happen in IoT network? And then how can you save your system from that? That could be another project, okay? Then botnet concept is already there. Now, knowing that you are under attack by a botnet is also a challenge. So how do you know that you have been attacked using botnet? So you can do that by analysis of the traffic, network traffic. So you have to come up with some algorithms. So this is another project you can work, not one, many. And finally, you can propose a secure architecture for IoT ecosystem. So you must know, you must understand that IoT is yet to be standardized. So you do not have a single standard, although there are some protocols which are standardized, but as a complete system, it has not come up yet. So you can always think of having, of course, it is not easy. It's a very large project, but there is no harm in trying to do something big, right? So you can try to propose a secure architecture for an entire IoT ecosystem. Okay, so which will be able to defend, say, denial of service attacks. So you can think of designing the strategy first, then devise the algorithms, and finally you have to evaluate. If you propose an algorithm, you have to evaluate its strength. So that can be done in the context of IoT through Contiki OS-based CUSA network simulator. So CUSA CWJA is a network simulator which is extensively used for IoT research. You can do that, and it assumes that it actually uses Contiki OS. Okay, so these are various project ideas you can try. Okay, similarly, you may think how can you provide the security at the transport layer or network layer. Okay, so these are various project ideas. Please try to think about something, and if you want, I am always ready to work with you for this kind of projects. Okay, and you can take it up, and let me show you the RFC. So what is it? I'll just show you, and then you must download it and read it. If you are ready to do something in IoT, first read this particular document. Okay. Yes. Have you seen my screen?
Yes,
Have
sir.
you? So this is a document which is available in internet. You can search. So this is the group of people who worked here. O. Garcia Morton from Philips, S. Kumar Signify, M. Sethi from Ericsson. They published it in 2019 April. So it is submitted to. It was submitted to Internet Research Task Force, and RFC number is 8576. Request for comments, and finally it was approved, and this is the ISSN number. Okay, and here the details of IoT security is given. This is a complete document. You please read this. Okay, very big document. If you know this document, if you understand this document, you actually know a lot of things about IoT. So I am showing you one common single document, which if you read, you will know a lot. Only one thing I can show you from here, which is necessary to understand. Yes, look at this. This diagram is actually depicting the life cycle of a thing in Internet of Things. So IoT stands for Internet of Things. You know this. Then what is a thing and what is the life cycle of that thing? So this is that life cycle. So this is the start point when it is manufactured, then installed, then commissioned. So commissioned and installed. In between this process is bootstrapping. So bootstrapping happens here, and then finally it is commissioned, and then application is running. So when application is running, in between software update happens. I was telling you that software updates must take place, otherwise you will always remain vulnerable. Then maintenance, in between you do maintenance and rebootstrapping. Okay, again the application is reconfigured and it is running. So this is operational. And finally, someday that thing will be decommissioned. Okay, that thing will be decommissioned. Decommissioned means it will be stopped, and then you remove it and replace it by a new thing. So this is called maintenance and rebootstrapping. Okay, this is called maintenance and rebootstrapping. Okay, and then re-ownership and recommission. Re-ownership and recommission means you start that thing with a new, I mean, you replace that thing with a new thing and you start the same process. So this goes on. So this is the life cycle of a thing in Internet of Things ecosystem, right? So this RFC you should read, and a lot of ideas you'll get. Then I think I have told you about some project ideas. Also, I have showed you this RFC and some basics of IoT security thing we have seen. Okay, so 1.5 hour presentation, lot of things cannot be done, but still secure routing and authentication, these are some important areas where people can still work. There are a lot of scopes in doing some research in these areas. Okay, so with this I'd like to conclude. If you have anything to ask, I am ready to do that. Okay.
Sir, thank you so much for giving your valuable insights on this topic. So with that, we'll go ahead and take some time for questions. Sir, we have provided some of the questions in the chat box. Can you just have a look at it?
Okay, system.
So we've got many questions, but due to time constraint, we had to filter some of them. So
how an antivirus software secures our devices from an external threat. Antivirus software can protect you from some threats, but not from all. For example, if you have a malware installed in your device, then this antivirus software will not be able to remove it, right? And this is the problem with something called ransomware kind of thing. Okay, so antivirus has strength. I'm not telling that it is useless. It is useful, but not having all the power to protect your device. Okay. Then next question is, almost every Google services or apps require most of users' personal data and device permissions. How can one say that our data is completely risk-free from our personal data leak in data breaches? True. So this world is running on trust. So whenever we are taking these services, we disclose this particular data to these entities like Google, etc., with a trust that they will not leak our data and they will not make use of our data for wrong things. So that is a trust. So with on the basis of that trust, we are running. So no one can guarantee. So tomorrow, if they want to do something, they can do it. Okay. And then third question is, OT voice controller devices like Amazon Alexa and Google Home are basically microphone in your homes that record conversations and stores the on servers owned by the device provider. Okay, should we prevent the use of this kind of voice controller devices? Now that's up to you. You know already what is happening, right? So now you have to take that decision whether you should go ahead with it and you should stop using that. Problem is when we do not know what is happening. But here you have rightly said, and you also know what is happening. So you can take the decision. It is your own choice. But sometime I am scared, therefore I do not use many high-tech applications too frequently. So it's your personal choice. Okay. I think we have addressed. Is there anything else?
Yes, sir. We have one more question. As the coming youth, what is expected from us towards bringing about progress in the development and secure environment for IoT devices?
See, first thing is awareness. So you have to be aware what is happening, and then you have to make your own choice what you intend to do. But it's a very, very big game. A single person hardly can do anything here. So this launching of a particular application, it's not easy. It goes through a lot of decision making processes, and finally it comes to the society. Now, whether that is a good application or bad application, these debates are always on. Debate is going on. So, as an individual, I don't think I can make a change in promoting a social network or stopping a social network, for example. But what I should do, I should be aware myself at least. I must understand what is happening, whether it is right or wrong. And then accordingly, I can take my decision. I have to choose this side or that side, right? I may use it, I may not use it. If I use it, this is going to happen. So, this way, my suggestion will be first you become aware of everything and rightly, not wrongly. You should know the truth. You try to know the truth. Once you know this, then you take a decision and also let your friend know about the truth, right? So before using a technology, you should be, as you have said, that as a youth what we should do. So it's a very, very big role. As a youth means, I don't know whether you are indicating yourself only or a group of youths. Now it is not easy. Let me tell you, Java technology. Java was not the only language of that kind. There were many competitors like Java, but nobody knows about those things because they could not win that game. And finally, Java could win, and Java was made a technology to be used worldwide. What I mean to say, in order to establish a technology in the society, it goes through a lot of actually difficult processes. There is lot of things actually in between. So developing the technology is one thing, and establishing it in the society is a different game altogether, right? So when it comes to the society somehow, for example, IoT has come to the society in a big way and it will be there for long. Now, as an individual, hardly we can do anything, but we have to be careful and you should make people aware. That is the best thing. First, you understand the security aspects, you understand what is possible, what is not possible, and then make your surroundings aware of that and help them in using it in a secure manner. That's the only thing you can do. I think so. Okay.
Okay, sir. Thank you so much. So, with this, we have come to the end of our first day of the workshop. We are very grateful to Professor Hiren Kumar Deva Sarma, sir, for taking out time to conduct this workshop. I would also like to thank everyone who have attended the workshop today. Though we got a lot of questions, we are not able to answer all of them because of time constraint. And thank you all once again. We will be providing a Google form link in the comment section. You need to fill up the form correctly to get the certificate. Thanking you all once again for joining. Thank you so much.
Thank you, everyone, and we hope to see the same excitement and enthusiasm tomorrow as well. So please join us for the sessions tomorrow as well. Thank you. Thank you, sir.
Okay, welcome. Then I'm quitting. Okay.
Yes, sir. Sure. Sir, could you share the PPT with us?
Yes. I'll email it to you. Okay.
Okay. Thank you, sir.